Okay, so and we are now live. So, hey everyone, welcome back to the day two of This is Learning conference. So, I hope you have enjoyed the day one, and day two is also gonna be amazing. We have some great line of speakers as well here with us. So, get ready for the AIML track and get ready for to hear some interesting and amazing talks. So, first up on the list of the speaker is Xavier. So, Xavier is gonna be speaking about build conversational AI experience powered by LLMs. So, without wasting much of our time, let's get Xavier up to the stage and let the talk begins. Hey Xavier, welcome to the stage.
Hello everyone. Thanks for joining today, and thanks for having me. Thanks to all the TIL conference for hosting this. So yeah, it's a pleasure.
Awesome. So maybe you can start by giving your introduction and then yeah, we are good to go.
Yeah. Here we have the slides. Perfect. So yeah, as Manish said, we are gonna talk about how to build conversational AI experiences powered by LLMs. When we talk about like the conversational AI, like when we want to build chatbots and all that stuff, and we want to create like real conversational AI experience with complex agents, not just using ChatGPT and querying a knowledge base. So that's why this talk is all about. As Mani said, I'm Ser Portiaedo. I'm working as a head of cloud infrastructure. You can find me in all the social media accounts at Shavidop. So feel free to reach me out there. Um, in terms of the recognition, some of the ones that I have are like GitHub Star, Google Developer Expert in Machine Learning, and also Alexa Champions. So this is the today's agenda. I'm gonna go like a little bit quick because we have only around 25-30 minutes. So we will see we can have time for the demo time. But basically, we are gonna talk about all the layers that are involved in a conversational AI field. Basically, when we are talking about conversational AI plus the usage of LLM. So first of all, let's talk about the key layers. The first layer, it's all about like large language models. So before explaining all the layers and all that stuff, let's explain what is a large language model. Basically, a large language model are ML algorithms that can recognize, predict, and generate human language. Basically, you say something or you send something to the LLM and then it will generate an output from an input. It generates an output. There are multiple LLMs. So yeah, we will talk about all the LLMs that are available. They are pre-trained on petabytes scale text-based datasets, resulting in large models with tens to hundreds of billions of parameters, as you have seen with Llama, Gemini, GPT-4, GPT 3.5 Turbo, all of them. They have like billions of parameters. Um, the LLMs are pre-trained on a large corpus of text, and it takes a while. And also, the cost of training an LLM is huge, and it requires a lot of computing. So that's why, like, mainly the big corporations are the ones that are training these LLMs, like OpenAI, Microsoft, or Google. The LLMs are also called large models. And when we talk about the LLMs, basically is when we are talking about generative AI. The large language models that we can see out there mainly are the ones that generates text, like the GPT-4, like Gemini, Mistral, Llama 3, all of them, or Gemma, all of them are the ones that we use to generate text. There are another ones that are more specific to chatbots. They were trained with a different corpus, or fine tuned with a different corpus, and basically they are good at tasks like leveraging chats experiences like ChatGPT, for example, for multi-tone conversations. Then we have text to image. Those are the ones like DALI 3, like Imagen 3, all the ones that basically from a prompt you create an image. There are APIs for text and images. That's one of the most important things of the generative AIs. Like thanks to these APIs, like the OpenAI APIs, the Gemini APIs, the all these, like the Bedrock on AWS. All those are available through an easy to use API, and basically it allow the people, or it democratize the use of the AI, and also the use of the generative AI to everyone, because it's really easy to use and to interact with. Speech to text, that's also another type of LLMs that we can see. And code generation, like GitHub Copilot. I'm pretty sure that all of you are familiar with Copilot, or probably you used Copilot back in the past. So those are other LLMs that we usually see. These are the three key layers that we are gonna touch today. The first one is the AI foundation layer, which is basically the large language models. Then we are gonna add the data layer, and then we are gonna talk about the orchestration layer. That is a more broader layer. So, with that being said, let's start with the first layer. As I said, what this layer involves is basically the large language models, fine tuning, and prompt engineering. Basically, what we can see here in this layer is when we are just purely interacting with an LLM, when we have a prompt and then we have an output. We can say that this is conversational AI because there's an AI involved, but it's quite basic. It's just like if you are using, for instance, an LLM that is for chatbot experiences, or just Gemini, for example, or GPT-4, that will work. Like if you use like LangChain or any other framework, you can say a prompt and then interact with the output, and then like you can send the conversation history and all that stuff, which is good, but probably quite basic. And this is something that we are seeing a lot when you are interacting with ChatGPT, for example. Is this kind of like you are interacting just with this foundation layer, just with the large language model. But the large language models, they were trained based on a corpus, and that corpus was like trained, for instance, in 2021 or in 2022. So what happens if there's like something new? In this case, for instance, um, we are asking for the world record of diving, and that was the new there was a new world record in 2023. But since the LLM was trained in 2021, the LLM is basically saying that the world record was in 2021, but by Molchanov, who dove 80 meters. But that's not true. So these are basically one of the limits that the LLMs have. So to solve this, we have the AI data layer. The AI data layer, what we can find is basically what we call knowledge bases, and also the what we call the retrieval augmented generation. What we are gonna do in this layer is basically add um, to our large language models. When we are interacting with them, we are gonna add a better context based on some documents, websites, some information that is outside of the LLM. How are we gonna do that? Basically, the how all these knowledge bases on all these vector databases and all those things, how all they work is basically, um, you upload or you, imagine that you have like a base of PDFs. You transform those PDFs into chunks. That is like, for instance, paragraphs, or like between text between full stops and all these kind of things. There are like multiple chunks algorithms that you can use, but you will transform that into chunks. Those chunks we are gonna call an embedding model. That's another AI type of model, and what we are gonna get is a single chunk. We are gonna like they are gonna have um how's it called, a vector value. Okay, so we are gonna have the chunk, and then the vector value, a numeric value. Okay, and then we are gonna store that information in a vector database, because we have a vector, and those, to store that information, we need a vector database. Why a vector? Basically because what the embeddings model is or are giving to us is basically the the distance between the chunks, like how different they are. Okay, so why we need to set all these knowledge bases and all that stuff? Basically, when we are like interacting with an agent, a conversational AI agent that is using the large language model, we can first, what we are seeing here is we are gonna ask a question. Okay, can you help me choose the most suitable mobile plan? When you have that question, we can like power that question while giving more information, giving like a better context, or like information from that user. For instance, this user is age of 16, and the data usage is greater than 50 gigabytes. Then when we have that question, what we are going to do is basically search for relevant documents. Basically, we are going to go to our knowledge base, and we are going to say, okay, this is my question, give me the chunks that are more relevant. That means that this question is going to be transformed in a vector, and then we are going to execute a search to the vector database to retrieve the closest chunks that are related to this question. Okay, so we got the chunks. We can augment the query with additional user information and conversation text. Basically, at this point, we have the question with information from the user, and then with the information from the knowledge base. Basically, that is going to be like a huge prompt. Basically, that prompt could look like there's a user that is asking this question. The information of the user is this, and then there are like these uh, documents that has this information. So that is gonna be the prompt, and that we are gonna send to a generative model. Basically, the generative model with all the prompt, the context, the augmented query, we are gonna get back the it will generate a personalized response, summarizing, like the everything, and we will, or the user, what he or she will see is basically response using natural language, or a human language that he or she could understand, which is awesome. So that works, like, for instance, on the first layer, we have just the LLM. On the second layer, we have the LLM plus a knowledge base with all the things that we have told about the chunks, the vectors, searching in the vector database, embeddings, like calling to the LLM and generate an output with a bunch of extra information. But like that works, but whenever we want to create like a complex agent, for instance, like instead of a frequent ask question bot, which was something that we can easily build with with the first layer and the second layer, when we want to build something like, I would say, like a bank assistant, a bank agent, that is not enough. So for that, we will need like an AI orchestration layer to create those conversational experiences. Basically, here is like a comparison between the LLMs versus the virtual agents. The LLMs are good, like to generate output. They are, like generalists trained on a large corpus of text. They could diverge, basically that they could um, go from one place to any other place in the conversation. And the on the other hand, the virtual agents is basically when we want to create something that is more, like focus on one action. Like for instance, if we are talking about like creating a bank agent, and we want to retrieve or make a transfer, for example, the agent, the virtual agent, is the one that is going to help us to go to that path, to go to that way. So this is the solution that we can find in Google Cloud Platform. Basically, what the knowledge base that we have mentioned is the service is called Vertex AI Conversation, and you can create data stores. On the data store, basically, you can upload a bunch of documents, or you can add like structure and structured information, websites, a bunch of types, and it will create those embeddings, and it will and those vectors, and store that in a data store. It's a no code way of doing that, and in like 3 steps you will have a data store ready to go. The data store can be connected to Dialogflow CX. Dialogflow CX is basically a no-code tool that you can use to design conversation. It is based on flows and pages. So basically, you can go from one page to another and designing conversation as flows. Dialogflow 6 at the end is basically like a state machine manager. And then you have the large language models under the hood that you can use from Dialogflow 6. In this case, is Gemini, Text Bison, Gemini Pro, and all your assistants or agents can be integrated to any channel, any application that you want. They have an API that you can use, like WhatsApp, Telegram, and all that stuff. This is how it looks like. Basically, here you can have the flows, and then you have the pages. Basically, they call it pages, but those are nodes. So you are gonna go from one node to another, and then you have like a simulator that you can use. Within there, you can call a data store to query a data store, a knowledge base using LLM. You can create a generator that basically is a call to an LLM directly, and there's the generative fallback. The generative fallback, what it does is basically when an agent detects something that is not in the design of the conversation, it will call an LLM to try to push back the user to the conversation. This is like all the spectrum of the conversational experiences that you can find on Google Cloud, but basically is from left to right. What you have is more deterministic and more generative. Okay, and the more deterministic, of course, what we have is Dialogflow CX, which is basically a conversation as a flow. Then you can add a data store to the Dialogflow 6 to query and call the LLM, and to query information from from documents and all that stuff. Then we have the generative fallback. That is what I explained already. Then you have the generators. That is basically something that you can create to call directly to an LLM that does not have like data stores and anything. It's just an LLM. So basically, instead of creating like a webhook, or like, or serverless functions that call Gemini, you have a built-in solution to do that. And then you have the Gemini API. Like at any time you can create, if you want something super specific, you can create like a webhook that calls the Gemini API. And then the more generative way, that thing that we have is the Vertex AI agents that I will explain in a bit. Another solution that was on Google Cloud Platform, and in this platform, what we have is VoiceFlow. That's another platform, but it's like super similar. The main difference between Dialogflow 6 and VoiceFlow is that the conversational AI experience and the conversational design experience is way better and easier in VoiceFlow. But it has exactly the same. You have the knowledge base that you can create, VoiceFlow as a state machine manager that interact with the knowledge base, with the large language models. And like, it is also based on flows that you can go from one flow to another, and you can drag and drop blocks instead of notes or pages. Here at VoiceFlow, or in VoiceFlow, is called flows. And then you can call large language models like GPT-4, Cloud, Gemini, etc. And those can be integrated in multiple channels, because it has like a very similar API than the Dialogflow 6 one. And this is how it looks like. In terms of the spectrum, what we are gonna find here is basically kind of similar. We have the canvas, which is the this thing where you are gonna drag and drop blocks. That is the more deterministic one. And then you have the knowledge base. You can query a knowledge base in a block. There's a block specifically that you can query a knowledge base. There's another block specifically to call an LLM, which are called generative blocks. You can choose the LLM that you want to call, and then the LLM settings, and then you can use voice flow functions to call to any LLM API. So that is from more deterministic to more generative. And if you want to build this open source, we have this option, which is as a virtual agent, like a state machine manager. It's going to be like LangChain or Rasa, for instance. As a data store, you can use Quadrant Vector Database. And then on the generative model, you can use any. And you can deploy that to like a Kubernetes server, or to Cloud Run, or to like a serverless function or whatever, to any server, and expose that to an API and integrate that with multiple channels. We are running out of time, so I'm gonna skip the demo, but I want to show you the future, like what is next. um, Remember that I said that the Vertex AI agents is something that I'm going to explain in a bit. Now it's the moment. Vertex AI agents is another way of creating conversations. In this case, what we are going to create are playbooks. And you are going to set the, like the playbook name, the goal of that playbook. Like in this conversation, or in this part of the conversation, the goal is to, for instance, like make a reservation. And then in the instructions, you are gonna tell to the LLM what to do. Like first, greet the customer. If they are like, let's say that this agent is to like to make make a reservation, for example. You can specify, like, ask the here in the instructions. You can say, as the user for the day, as the user for the location, as the user for personal data and all that stuff. And you can like put that there, but this is managed by the LLM. This is managed in this case, because this is a Google Cloud specific platform. This is managed by Gemini. So we have Gemini, then we have Gemini functions, and on top of that, we have the Vertex AI conversation with playbooks. You can go from one playbook to another. Uh, for instance, like let's say that you have like a bank account agent, you have you can have like a playbook to make a transfer, another playbook to retrieve like the balance, for example. And this is another option, which is the Alexa LLM. The Alexa LLM is the same, exactly the same concept. Here you have like the main information, but at least for me, this is the feature, and this is how we are gonna move to, instead of like having conversations based on workflows and calling LLMs. What I'm seeing is that we are gonna have probably like workflows as well, but then like to be more or less diverged, but then some parts of the conversations are gonna purely managed by the LLM. Just some conclusions. Basically, when you are writing your agents, like choose the proper data that you want to upload to the knowledge base. Design your conversation properly, like not having, for instance, a huge knowledge base. You can create like multiple knowledge bases, and depending on the conversation flow, you can query one knowledge base or another. Test and test and test and test and test your assistants. That is one of the most important things, and that's pretty much it. Here are some learning resources that you can use, and with that being said, thank you. And if anyone has any questions, happy to be here. But yeah, thank you everyone, and thank you the TIL conference people to host and create this conference. Thank you very much.
Awesome. That was really an amazing and interesting talk. I hope everyone should have learned something from the talk. So yeah, thank you Xavier for this interesting talk, and letting us going through like the realms of LLMs, and like how we can navigate through it. So yeah, it was really insightful. So thanks a lot for like coming here and giving that talk.
Thank you very much. Thank you very much for having me.
Okay, see ya. Have a great day.
See you. Bye bye.
Awesome. So I hope you all of you enjoyed the Xavier's talk, and I think the next speaker, I think most of you have know her. So the talk is gonna be amazing and interesting as well. So without wasting much of our time, let's invite our next speaker, Hemantika, and she will be speaking on what the heck is RAG.
Hi, everybody. Can you hear me perfectly, Manish?
Yep, your sound is perfect and clear. So welcome to the TIL conference, Hemantika. How are you feeling
Thank
today?
you so much. I am very excited because, AI has been, every tech company or every developer is either using AI or talking about AI. So I'm very excited to be talking about one of those popular terms that the AI world has been seeing. So yeah, I'm pretty excited to be here, and a big, big thanks for This is Learning, Santosh, and the entire team for organizing this conference.
Yeah, we are excited to have you as well. And the topic is as well interesting. Well, what is early like. So yeah, like we can start it. You can introduce yourself, and then yeah, we are good to go.
Amazing. So what I'll do is I'll share my screen since I have prepared a very nice slide introducing myself. So I'll share my screen and then I'll go from there. Just give
Sure,
me a
sounds good.
second. I'll need your help to know if you can see my screen.
Yeah, you can just share the
And
screen, and I will
yeah,
like make it visible.
okay. So I think it should be visible. Just give
Okay.
me a
So, yeah,
second.
yeah. Let me end it to the stage.
Yeah.
Okay, it's easy. So yeah, the stage is all yours.
Amazing. Thank you so much. So, hi everybody. I hope you are enjoying the conference. The first day of the conference is already over, and this is the second day. And today I'll be talking about what the heck is a rag. So I'm sure that a few months back, or maybe almost a year back, most of us knew the definition of rag to be a piece of cloth. At least that's what I knew. But ever since generative AI has been the talk of tech town, it's a term that is being used almost in every AI tool that is being built, or even if you are building some side projects, you must have heard about rag, or you must have done something with it. And if you haven't, then this talk is for you. So hi everybody, and I hope you learn something out of this. So in the next slide, I'll just introduce myself. So yeah, that's me, as you can see me here. Hi once again, I am Hemantika Mitra, and I'm currently working as a developer advocate at Hashnode. And other than that, if you would like to know more about me, go to your terminal, and I hope you have npm installed. So just type in npx space hello hyphen Hemantika. I made this cool package to show off in talks like these, where you can go and learn more about me, have access to my portfolio, and just get to know more. But other than that, a very short intro that apart from my work, I have been in this industry for almost close to 4 years right now, and I have been a developer advocate for 2.5 to 3 years. And before that, I used to work as a support engineer at Microsoft. But other than that, things that I really like. So if you would tell me one word to introduce myself, that would be I'm a generalist. Like, I really like tech. I love hacking with front end technologies and also AI right now. And a little bit of Rust. I just know how to write hello world in Rust, so that's it. But in general, I'm a person who loves tech and also communities, and I love people. I love developers, being a developer myself. So yeah, that's about me, and I think that's enough. But let's go to the next slide, which is about what is a rag. Like, what the heck is it? So rag, by definition, it has, like, it's a shortened form of, or an abbreviation of, retrieval augmented generation. So the two keywords that you need to remember when it comes to rag is retrieval and generations. And what does it do? So it's a natural language processing technique. Basically, natural language, what it means is, whenever you're going to an AI tool and you're saying something like, hey, how are you, like, we're talking in natural language, it should be able to understand that. So similarly, that's what natural language, the processing technique is all about, and there is more details about it that you can learn from. But what rag does is, like, it's an NLP technique, like natural language processing technique, that is combining the strengths of both retrieval. Like, retrieval basically means getting or taking, and then generating or giving based artificial intelligence models. And the reason why rag exists is because it can deliver accurate results that also make the most of pre-existing knowledge, but can also process and make use of the knowledge that you are providing to create more accurate, unique, and contextually aware answers or instructions or explanations in human like language. So for example, chatbot, I suppose you are building a startup, and your startup is, let's maybe a pizza making startup or something like that. So, and you want to have a chatbot that can tell your customers about all the different types of pizza that you can make. So this is where you need to build a chatbot, and this is where rag can play a very crucial role. Like, you need to tell them about maybe you can populate it with some existing knowledge about pizza, and also give new knowledge about the kind of pizza that you deliver or make, and then make a chatbot or depending on that. So that's the basic, or what, if I had to define rag in terms, that's what it means. But if I had to give you an example, sorry, I'll be zooming out, and I'll be going to ChatGPT, and let me ask you the question, like, who won cricket World Cup 2023? And you'll see that it is not able to answer. It says that I was last updated in January 2022, so I do not have information of any events that occurred after that. For all the Indian cricket fans, I'm sorry that I had to bring this topic up, but then it's a nice example, right? That if you had to train the LLM on recent knowledge, then it doesn't have any of this pre-existing knowledge. So you need to give it the information about the recent happenings. So this is where rag comes to play. And now I'll go back to my slide, and I'll explain you how it exactly works and why you should build it. Like, I gave you a demo of why you should build. And now we'll talk more into details about the why. So first is to have more contextual depth. For example, when you're building a RAG, it acts specific information to LLM outputs. For example, if I were to build a chatbot that gives you information about cricket, then I would also, and it I need it to be updated, then I would also add information about the last cricket World Cup or even about IPL, so that it can understand and also respond accurately. And this is a very simple example that I just gave an example of, but there are more complex use cases that you can think of. And also about real time updates. For example, um, like uh, IPL is still going on, and you need your cricket chatbot to give you updates about who is winning right now, or maybe who is winning, who won the match today, or maybe what are the upcoming matches. So it should also give you real time updates. So whenever you are solving a use case that requires depth, that requires real time updates, that is where you build a RAG. And also for resource optimization, for example, whenever you're building a RAG, it reduces the need to train extensively on data sets. Those who are aware of ML, or if you are not aware of ML, you must have heard about the high, that it needs very powerful machines to train it, and then it's a very long process as well. So if you're making use of a RAG, it means that there is an LLM that's already there, and you're just making it more powerful or more accurate by building a RAG. So these are the top three reasons why you build a RAG. And in the example before, I also showed you, like, when there are use cases as such where you need updated information, that's also another reason why you build a RAG. So that's about what a RAG is, why you build a RAG, and when you build a RAG. Next is, how does a RAG work? So this is an image that I have taken from Turing.com, as you can see. So this is basically explaining to you what RAG does, and as you can see, like, there are mainly three parts that it has been divided. So for the first one is called the encoding part, then we have the DPR encoding part, and then we finally have the generating part using LLM. I'll be showing you with a demo about how we go about building all of these, like a very simple demo. But if I had to explain you what it actually does, so RAG, it is making use, or it is leveraging the pre-trained LLMs to generate text, while also incorporating a retrieval mechanism. Like, it is retrieving information from something, then it is feeding the LLM, and then finally it is generating you an information, or accurate or updated information about that. So what it does is, like, it allows the model to access external knowledge sources or knowledge bases. Like, in a lot of use cases, I've seen people using a website as an external knowledge. For example, maybe if you are building um, a website where you wanted to have so for example, if you're building maybe a chatbot, or an application that is making use of the information that's, or the knowledge base that's there on a website, that's where you can use that as an external data source. Like, the data source totally depends on what you want to use, but that's an example that I mentioned. And now you must have seen about this award, like about DPR encoding as well. So it stands for dense passage retrieval, which means that it this is a technique that RAG, or retrieval augmented generation, uses for information retrieval in large language models. And it is very crucial component of RAG framework, because it is serving as the first step in the two-step process that RAG employs. So the step process that RAG has is retrieving and then generating. So what RAG basically does is, like, it there is an LLM, it is making use of that, then it is also using making use of an external data source to get the most updated or accurate response. And then it has, like, with depending on all of these, then it is generating you a response or instructions based on all that has been fed into the mechanism. So that's how, if I had to explain how a RAG works, that would be it. Now, the next step would be that how to build a RAG. So the first step, in most AI or even ML algorithms is to collect data. So gathering essential data, like I'll be giving an example of chatbot again and again, because that's like the best use case I could think of, especially if from beginner perspective it's the easiest one to understand. So if you were to build a chatbot, then it needs a knowledge base. Like there needs to be some data that can be manuals, product database, or even FAQs that is relevant to the application that you're building. Like the example like I mentioned, maybe a customer support chatbot. For example, if you like I mentioned that I was working at Microsoft, and then let's say I had to build a chatbot for Microsoft Exchange. So I would be using the knowledge base, the documentation, and everything that I have as the data. So that would be the data I collect. Then the next step is data chunking. So what it chunking in, in plain English, it means that you are breaking something into chunks. So just breaking down the large documents into smaller topic focused chunks, just to enhance relevancy and also efficiency in data retrieval. So this is a process that is needed. For example, we talked about chatbot, for your pizza making startup. Like there might be a manual about how to build a farmhouse pizza, and then there might be a manual about how to build some other vegetarian pizza. So if you are breaking this entire pizza manual into something like a vegetarian pizza or a plain cheese pizza or something like a non-vegetarian pizza, so that would help the chatbot have more accurate response. Like whenever you're asking it that, hey, I want to order non-veg pizza, it can learn, or it can retrieve the knowledge that is had from the data that you have chunked in different parts before, and then it can retrieve the text from there and then give you a response depending on that. Then the next part is document embeddings. So basically what you need to do in this step is you need to convert the text data into embeddings or numerical representations that capture the semantic meanings, and it enables the system to match the queries with information that is available on the content. Like I mentioned right now, that if I were a user, and if I were asking your pizza making chatbot that, hey, I want to order a non-veg pizza, that's where it would go back, get me the data, and then give me the relevant information. And the fourth step is just how to handle queries. So you need to transform these user queries into embeddings using the same model that you have used for documents to maintain uniformity. Like there shouldn't be much difference, because that's how you'll train it towards more accuracy and relevancy. And then the final step is to generate response. In the demo we'll see how we are using a model from OpenAI to generate the response. So similarly, you will be using a large language model to generate the response based on the data that you have chunked and the query that you have also trained your data to handle. So that's the five major steps that are needed to build a RAG. And so far, just a recap of what we have done is we have learned what a RAG is, why or when do you build one, and how, well, like what is the basic functioning of a RAG, what is a DPR, what is the retrieval and the generation part, and what are the steps that are needed to build a RAG. So that's the basic foundation of RAG that can help you start building complex the RAGs as well. Now there is this topic about, like, there is this is a very common confusion that most people have, that is about RAG and fine tuning. And if you would like to know more, there is a talk in this conference by Aravind about fine tuning. So that is the talk that you need to watch if you want to learn more about fine tuning. But in general, what RAG does is it is merging your real time data retrieval with text generation. And what fine tuning does, like the name stands for it, that something is already there and you are just making it finer, or you're just making it better. So what fine tuning does, it is adapting the pre-trained models to specific tasks via additional training. For example, previously when we used to build chatbot, like I we had to train the chatbot by giving it some data that, okay, let's say I want to build a chatbot that can answer me queries about pizza again. So I would just go and say that, okay, what is a pizza, or how do you make a pizza. Like I would give it similar kind of responses and fine tune it so that it could give me a good response towards the end. And then the second difference is that RAG, the best use case that I mentioned in all my slides is that it's used for dynamic or real time tasks like chatbots, but um, fine tuning it is effective in some domain specific tasks, for example sentiment analysis. That is where fine tuning, like the more, let's say like the more kind of tweets, if you are doing a sentiment analysis of tweets, the more kind of tweets you send it, that okay, these are the kind of tweets that means it has a neutral response, or these are the kind of tweets that are happy tweets, these are the kind of tweets that are sad tweets. The more you train it, the better it adapts and can give better response. And then what a rack can help you with is with accuracy, and then it is also making use of external data along with LLM to make give you accurate result. And what fine tuning does, it is leveraging the depth of pre-trained models, like you're not using any external data, but you are fine tuning the models that you already have, like it's going deeper and deeper into the models or the pre-trained models that you have. So that's about rack versus fine tuning. And if you have more questions, like I mentioned, you can ask me in the chat, or you can also go and attend the talk by Arvind on fine tuning. That's where you learn more about fine tuning. And now it's time for a demo. So I'll be not building from scratch, but I'll be showing you a demo that I have already built. Here I have a sandbox, a code box environment, code sandbox environment that I have created. And this is a code that I have written. So what I'll do is I'll maybe zoom it a bit, and I'll also reduce the output size so that you can see it better. So I'll give you an example of what this does. From this demo, you must have understood that it's PDF document summarization. Like it's a very simple demo, but it can help you understand how exactly, like how to build a very basic rank. So what we'll do is we'll write the code, like the code is already written. I'll explain you step by step. So what I've done is I have written code. The first step that we need is that we want our application to read the PDF page by page. And the next thing is that I'll give it, like I talked about having external database, and in this example, instead of a database, I'll be using some static or hard coded knowledge base or corpus that they'll be using. And then retrieving that data plus reading and summarizing my PDF file that it already has. That is using both of it, like retrieving the corpus that I have plus reading my file and summarizing it using using OpenAI models. That's where it will be generating me a summary. So let's go step by step first. So I'm importing some libraries, like I'm using Flask to build the entire web application. And the most important library that we need here is fits, or like it's to help you read the PDF. And then we also have some .env files just so that I can put in my API key, and that's pretty much it. The next thing that we are doing here in from line 13 to 16 is that we are just uploading the data, like we're just setting the path to upload the data, and which we will be doing from our application here that you can see on the right. And then I talked to you about corpus. So this is what is acting as our knowledge base. Like in more complex settings, you will be generating data from maybe a website or from lines of documents that you have. But for this small example, I have written some corpus, like just four. One is about climate change, the other one is about machine learning, the next one is about stock market, and the fourth one is about biodiversity. So what this application will do is, like, what is the use case of this corpus? I have told like I want my application or my rag to retrieve the data from here, and then also take in the PDF that I am providing, make use of OpenAI's GPT 3.5 model that I'll be showing you a bit later, and then finally summarize the PDF for me. But when it is summarizing the PDF for me, it will also look for um, data or phrases or words that I have mentioned in my corpus here, and then it will use this knowledge plus its own LLM knowledge, and then finally generating me a response. So in the next one, we are just extracting the text from PDF, like the PDF that I'm uploading here. It will extract the text, and then it will, like, read through the pages and extract the text. So that's what this function is doing. And then the next step, what we are doing is, it is retrieving the text, and it is looking for relevant phrases that's there in the corpus, like it's in text. For text in corpus, it's looking for those relevant text. And then finally, what we are doing is generating a summary for me. And for this, what we are doing is, we are using GPT 3.5 turbo instruct model. With GPT 4.0, I'm sure there are much better models that are faster and more accurate, but for this example, we will be using GPT 3.5 turbo instruct. And we'll be using its API, which is VUR/completions. So depending on the model that you are using, you need to read the documentation and update the API accordingly. But for this demo, we'll be using the model GPT 3.5 turbo instruct, and the API that we'll use is completions, like just to complete, or you know the, just to summarize the document for me. And then if there is some error, it will throw some errors, and that's pretty much it. So now what I'll do is, I will upload a file from my document. So let me show you the document real quick. So this is a document about climate change, and then it talks about climate change in general, and then it has things, it has some phrases like rising temperature. What I'll do is, I'll do a quick control F, and then when I search for rising, you'll see that it has this phrase rising temperature mentioned at least thrice. Now I'll go back to my code. Sorry, I'll just go back to my code here. And then if you see in the corpus, you'll see that here the first corpus that I've added is about climate change, about alteration of temperature, weather patterns in a place. So whenever it is reading text like climate change or rising temperatures, phrases like those, that is when it is retrieving the data that I have put in the corpus, plus also using the LLM model, and then it will generate me a summary of the PDF. So let's see a demo of that. I'll upload this PDF, and then I'll click on upload and summarize, and I hope that it works. Okay, so here it says that here's a summary. It's about the entire essay, like you saw, it's a two-page essay, and then it gave me a small summary of that. So that's how you can build a very simple RAG that is using the main two mechanisms that a RAG has, that is retrieving the information and then generating a response. And for all of these, you need two major things. One is an external database, and the next thing is you need an LLM model that the RAG will make use of to generate your response. So that's about the demo part. Now let us go back again and finish our presentation. So the demo is over. Now working of the demo. So just what I showed you right now, it the first step that it does is, it is I'm uploading and reading a PDF. So it's similarly like, imagine that I'm giving you a book and I have asked you to summarize it. So the first thing that you need to do is to read the book. And similarly, the application, what it does is, whenever I'm clicking on upload a file, it is getting uploaded, then it reads the PDF file, and then it extracts all the text that you saw in my function extract test. That's what it was doing. And then it is finding relevant information. So imagine the book that I gave you. Now after reading the book, you will remember certain information. So let's say if it is a book by maybe a a genre like thriller genre, or maybe a crime book as well. So you try to remember things like dates or name of the person or certain scenarios. Similarly, our application also tries to do that. And it also, what it does is, like, if I were to give a summary, I would also look up information related to that on my book. Similarly, that's what my application was also doing. Like, it does this by looking through the pre-prepared list of corpus that I had prepared. You remember that I had four corpus. One was about climate change, about machine learning, about stock exchange, and I don't remember the fourth one. But yeah, you could see that I had hard coded four corpus. So what my application would do, once it has read the PDF and then it has extracted the text, so it will look at some pre-prepared list of texts or corpus or knowledge base that I have added to look for matching keywords from the PDF. Like in the PDF, I was telling you to look for things like rising temperature or climate change, and these are some of the words that I had mentioned in the corpus. And once it does that, that is when the application tries to write a summary for me. And how it does this is by sending both the text from the PDF and the additional text that have put in the corpus, and also that is and they're doing it by sending through the OpenAI model, and then finally it is writing a summary for me. So that is all in all how the entire the flow of a RAG application follows. So it can be used to build more complex applications or more complex solution, but that was a very simple demo of how you can get started or you can learn about to just to know the basics or the working behind the logic behind a RAG. And if you would like to see the code to it, that is the the QR code that you can scan, and it will lead you to my GitHub repository that you can find some explanation about it. Like the explanation is all about RAG and how the entire code works, and the code has the code that I just showed you in my code sandbox. So if you can scan it, that's where you'll get all the information. And I see that we have 5 more minutes, so I'm pretty much done with my presentation. I hope you have scanned the QR. And the final one is links to my social, to my profile. So if you have any questions after this, be it related to RAG or AI in general, Gen AI particularly, and if not that, if you want any help from me related to career or community or anything as such, I'm more than happy to respond. And that's it from my end. I hope this short demonstration and this presentation helped you learn the basics of RAG, and I'll be waiting to see what you build. So that's it from me, and I'll hope you enjoy the rest of the conference. See you.
Hey, Amantika, thank you for the great talk. So, and
Thank
thank you for
you.
your time. And so Manish is not here; he had to leave. But yeah, I'm taking over
Yeah,
now. So, thanks again for your time.
amazing.
Just as Manish might have mentioned, like just wait for the recording to upload, and meanwhile,
Yep,
leave the StreamYard open.
perfect. Great.
Yeah, thank you. See ya. Bye.
Thank you. See you. Bye.
So, hey everyone, time for our next talk, and we have Felix with us. So, Felix will talk about AI for documentation. And over to you, Felix. I mean, we'll not take much of time. Just go ahead and start sharing your screen so I can edit. Can you do that? We cannot hear you, Felix, just in case
Is
you are.
my screen visible?
Now it is. So, yeah, over to you. I'll be in backstage. Thank you.
Okay. Thank you for having me. I don't know difference in time zone. I'm not sure if it's morning on your side or evening or midday. On my side, it's evening. So my presentation is about AI for documentation. We can start it right now. Just a sec. That was first. Okay, I'm Felix Jumason. I'm from Kenya, so the most common greeting that I can give is Jambo. Jambo is the most common greeting. On my socials are at Twitter or X, I'm Blackie_360. LinkedIn, I'm Felix Jumason, and GitHub, I'm Blackie360. Before we start, at least get to know me a bit. So I'm a software engineer. I'm also a postmon student leader at Kabarak University. I'm doing my final year. This remaining year. I'm also a co-organizer API Fest Nakuru edition. I love tech. I volunteer at Moringa School. It's a local tech community in Kenya and East Africa at all. On my free time, other than fighting bugs, and a bug can be a feature, but other than fighting bugs, I usually rollerblade. I roller skate. Mm, that's me touching grass. Mm. Okay, we can get right to them. Actually, in this session, you don't need to have AI experience to understand whatever I'll be talking about. So at the end of this session, you'll know how to leverage AI in technical writing and documentation. So first, before AI came, we used to do everything manually. Like back in the days, AI came around 20 2022. So before that, like AI wasn't that big. The first model that I came to know was ChatGPT, which is actually the largest model that I know. So before that, like we used to do it manually. So there are some challenges that I will mention, like the time consuming. Like AI has simplified almost everything, your day-to-day life. Before then, it was time consuming making documentation and writing articles. Um, Difficult in keeping information up to date. With the current world, everything is changing like abruptly. Right now, we have GPT 4.0, which usually uses voice. We have the Gemini multimodal media something, which will also be using voice and video. So like things are keeping on changing. It's hard keeping track of them. Writing back then in documentation, there was inconsistency in formatting and stylings. You might find like one page, one half of the document has this format and style, then the other half it has these different types of styles and formats. And then information silos, difficult in finding specific information. Right now, every browser, I'm using Brave. Brave has this feature whereby you can get AI generated answer, which is actually updated more than me going to read through different links searching for certain information. So AI is revolutionizing the world. Automating documentation and creation. This is the first slide that I'll talk about it into deep context. But later on, we'll also have it in a bit lighter context. So automating, what's automating? Automating is like you reduce the repetitive task. Like instead of repeating repeating something every day, like you can create an AI model or an AI chatbot, or just like create a logic whereby it will do it automatic without needing you to repeat it again. So in this, like we have some common things such as we have I'll talk about the Oxygen, which is a software tool that actually takes comments into generating documentations. So instead of you coming to create your own documentation from start, this tool helps you to generate the documentation using things such as the comments you've kept on your code. I usually like commenting my code. Like I believe it's me writing clean. I don't know writing clean code to you it can be what, but for me a clean code is the code that has documentation, has comments whereby I can know like at this moment what function was I doing, what function was I calling or creating. But like this tool has been used in C and C++ and Java. I haven't seen it in Python, but I found it more appealing. Like you just create a function, write a comment, you can generate a documentation about it. Other than this tool, we have one called Scribe How, which actually also does the same thing. You can give it a check. Automated formatting. The way I say that, one of the challenges that was faced before AI came, it was on how the formatting was inconsistent. You might find half a document has its own format, another half has its own format. So like with AI, actually it automates the tedious task of formatting a document. Instead of you just going page by page formatting a document, AI can help you to like give it a mono format, a one format throughout the documentation without you needing to just go page by page formatting. We have intelligence and proofreading. From the last speaker on RAG, her demo was about a RAG application that summarizes PDF. So like you like just like from the previous speaker, we can say like it can help you proofread. With these like AI is that powerful, I believe, okay, I'm not an AI expert, like, but I've been put on the AI ML track. So like you find AI is that intelligent that it can proofread your work fast. First, one thing, it will be faster. Another thing, it will be accurate. Like the typos, the wrong punctuations, it will capture all of it. So that thing is actually like, I've tried putting a whole document on Claudia 3, an anthropoth model. It actually summarized for me a whole document. Mm. So like, you can use AI to proofread. It will have minimum. It will reduce the minimalities of any change in your documentation. Mhm. I'd already talked about the repetitive tasks. So like, on this slide, I will give some examples of AIs that can be used to do some specific things, such as formatting and layout. I believe we all use Grammarly. For me, like, I can't write email. I just find myself, I've used Grammarly to draft an email. So like, it will have a format and a layout. You can also use it on large documents. Like, it will give you first a visual element across. Like, for me, Grammarly usually says that, instead of saying this, do the say this word, like, put your comma, put your question mark. Like, it's so nice. For content update, there is the oxygen that I had mentioned, and also it's called what? Just a sec. It's called Scribble How, whereby, like, your content will be updated when your code base change. When your code base change, it actually updates it automatic. It updates the documentation automatic. On the quality assurance, when you write first, like, when you write a document, or you're documenting something, the four pillars, like format, the content, the quality of whatever paper you are writing. It should be standard. With AI based proofreading and fact checking tools, actually you can scrutinize your whole document for errors, inconsistency, and factual inaccuracies. Uh, One tool that I've come across is Style Guide. It actually improves. It doesn't literally improve the quality of your paper, but it shows you where you might have under underperformed. We have the multilingual support, whereby your documentation or your document can be translated into multiple languages. Best tool is Google Translate, whereby you can use this Google tool to translate your document into different languages. Like, for me, I can translate an English document into a Swahili document. Swahili is my local language, which is mostly spoken in East Africa. I'm in Kenya. uh, I believe Santosha can can translate it into maybe a local language in Central Europe. My friend Santos can also translate it into Spanish. So you find, like, one document, it might have also been written in their local language but translated into English. The power of AI. We're in the age of AI. Everything is possible. So since AI is here, what role does human writers have? Some time back, we had Devin. Devin was an AI model, like an a full AI software engineer. It actually shook the tech space, like, okay, but we found out that it's a fake. So, mm, like, for me, so since AIs are here, Devin actually threatened. Okay, I don't know if AI will replace software developers. I'm not sure about that, but I do believe that I have some years for me to do what I'm doing before an AI replaces me. So, like, elevating the roles of human writers in this age of AI. AI will do for you the formatting, the proofreading, but as a writer, as a technical writer, before you publish your article or you are doing your documentation on a system, you have to unleash your creativity. AI can do these small tasks that are repetitive, such as the formatting, the layouts, the proofreading. But for you as a writer, as a human writer, you have to unleash your creativity. AI is creative. I've seen it's called what? This one for images. I've seen even Gemini producing very nice images. There is this one for ChatGPT. I'm not sure of the name. I don't remember the name, but it produces very beautiful images from prompts. Yeah. But still the same. You as a writer unleash your creativity. Yeah. AI has freed you from the repetitive tasks. So for you, you just have to like release your creativity, leveraging expertise. You can combine both AI and you to come up with a perfect document, mm, without relying fully on AI. Enhance collaboration. So like in collaboration is whereby you just have the human writers and the AI together, working together to bring out a very nice document whereby it will have everything, and it will also be user friendly. You can use AI to like suggest any user friendly techniques that you can be used. A driven continuous improvement. So by incorporating user feedback, as a human, like an AI can do some things for you, but you also need that user feedback. For you, it can spit out a paragraph that you are working on. Then after you reading it, you don't feel like it's nice to you. It's nice to you. So like you're providing that feedback. Like, can you tweak this a bit? Can you make it this more? The future of documentation. The future of documentation in this age of AI, it's actually if you go online and search AI for documentation, like you won't find mm, that much resources. Like it's enchanted territory. Yeah, it's uncharted territory whereby like people haven't actually invested on how AI can change the whole technical writers space and documentation. So like in this age of AI first thing it will enhance data analytics, whereby AI powered analytics in writing a document will be heightened, if not phenomenal. Whereby before I write a document, we'll have that context effectiveness of a document. Like even when somebody reads my document, I can go see how many people have interacted with my document. It will advance the data analytics in ways that I can't imagine at the moment, whereby when somebody reads the document then gives a feedback. Oh, so like these models, I believe we are still training them. They are using the data that we're inputting on them at the moment. Like when you just write a prompt about something, we are still training them. So like in the probably next few years, the models will be doing things without us even inputting these prompts. It may be voice or text. Like it will be nice. Guys in AI, there is something called natural language processing (NLPs), whereby it will enable the AI models or the AI interface or tools to interact with human languages more accurately. Like at the moment in Kenya, in East Africa, we are introducing this language called Nuru, a programming language called Nuru, which is purely written in Swahili, which is our natural language. So like, with the power of AI coming in, this language that it's being built at, okay, it's already been built and being used. It will have more capability than what it is right now, whereby anything that has natural language processing (NLP), I do see like it's for like we are all different. We find ourselves in different localities and speaking different local languages. So So with NLP, like you'll find yourself writing a prompt in your local language, and whatever the AI will spit, it will be it will be true to the T. Content automation. AI will automate content creation, like including writing, editing, and formatting, streamlining the documentation process. Here it will actually free time for this writer to work more to work more on the to work more on the data that he will need to input into the document, while the writing, the editing, the things that are usually repetitive, you write, you edit, and you format, the AI will be doing it. So for the writer will be more of finding the facts, which also AI can help you on finding the facts on whatever you're writing about. The new kid on the block was Apple Vision Pro, the AR visual reality glasses. So like while I was creating the slides, I actually fantasized about writing a document or doing my technical work, eh, in VR. Like how will it feel like? You're just in VR, and not typing on your machine. You're in VR writing your own, or documenting a whole system with a new, like it will be nice. It will be nice. I'd actually want it one day. Voice recognition. At the moment, you can only use AI for technical writing by typing the prompts. Like Hashnode has its own AI. I don't know if Journey. Oh, the AI for what? The AI for the images, mid Journey. I've just remembered it right now. So for the voice recognition, with the power of what just uh, ChatGPT, OpenAI has introduced, like we'll be more free. We will be rating our documents by just speaking some prompts onto the AI, and then it spits out some content. Personalization. Uh, I'm sorry. So for the personalization, what we say is usually garbage in, garbage out. Whatever you feed a computer, it's whatever it will give out. So for the AI, I do believe it's the same thing. Whatever you feed an AI is what it will give out. So for the personalization, the best way I can explain it is like we are all different. So like the content I might write is a different content that somebody else might write. So like the AI can be taught on whatever my preferences are, and my style of writing. So like when I tell it, can you create this document for me, it will do it on my style of writing, or not anybody's style of writing. I'm looking forward to it actually, on how like I can personalize my AI to just write the way I write, the way I used to write before AI came. Multilingual support at the moment, it's there, but it's not that heavy on other languages. It's only heavy on the common languages such as and Spanish, French, and maybe Italian. But these other small indigenous languages such as Swahili, it's not that strong on it. Enhance search and navigation. So like with AI, I earlier said about every browser nowadays. My browser, Brave browser, has the AI integrated into it. I can get both the organic answer and also the AI generated answer. So in conclusion, I've had a very short presentation. So in conclusion, learn how to use AI. I don't believe that AI will come to replace us anytime soon. I am a geek. I've watched Cyberpunk. I've played Cyberpunk. So like me saying that AI is there, we have to acknowledge that it is there the moment it is there. Okay? some time back, I used to ignore that AI. I was like, it will come and go, but AI is there. Big companies such as Google and OpenAI, Google IO extended. Actually, its whole keynote was all about leveraging AI, how AI will be integrated into most of their services. So AI is there. We have to use it. As a software developer or a software engineer, you have to learn how to use AI. You don't have to be an AI engineer or an ML engineer. You just have to know how to leverage it. So, any question? My handles on X, you can reach me at Blackie underscore 360. If you have any question on LinkedIn, it's Felix Jumason. On GitHub, I'm Blackie 360. I know I have about 10 minutes left, but I had a very short presentation. So
Hey,
for any
Felix.
question about AI, you can reach me.
Hey, Felix, thank you for your talk. It was a great talk. I mean, we know like we cannot avoid AI for sure. I mean, the one thing which you mentioned was really on point. Like if you want to grow as a software developer, right? So of course you have to use AI in some ways, and it's not like AI is going to replace you, but it's going to just like help you become more productive. So thank you again. We are still waiting for our next speaker. So in case someone has question, you can ask Felix or just reach out to him on his Twitter handle or not Twitter anymore, yeah, X or LinkedIn, and feel free to ask him a question which you want him to answer. Thanks again, Felix. And meanwhile, we can take a short break. So thank you so much. And just stay here, so don't disconnect. As we mentioned, like you need to upload your video, so just wait till it's completed.
No problem. Thank you, you and your team for the conference.
Yeah, thank you so much. Thank you so much. See ya. Okay, so we have our next speaker, Patty, and okay. So time for our next talk, and we have Patty already with us on backstage, and let's bring on bring her on stage. Hey Patty, thanks for joining. I just sent you a message on Twitter. I was like, okay,
Yeah.
how
Hello,
are you?
everyone. Thank you for having me. Yes, I had a confusion about the timing
Uh,
because I thought it was going to be in an hour. So, yeah, that's why I couldn't join earlier.
no
So,
worries.
yeah, if I can have a couple of minutes to set up the slides, I will
Yeah,
start.
sure. Okay.
Yeah, um, I will start sharing it, and we can start at 6 p.m.
Yeah, sure. Take your time. I mean, so Patty is going to talk about advanced generative AI integration with Vertex AI and Node.js SDK. So, going to be an interesting talk because nowadays everyone is talking about AI, right? So you just saw the Google I/O, and everywhere it was AI, and now OpenAI, which happened the day before AI. Now we are just waiting for Microsoft to announce something, and of course it will be an AI thing. And I was at GitHub Universe last year. It was all about AI. So I think companies are not launching product anymore. They're just launching a new AI. So
Yeah, it's just like that. Is we're in the middle of a AI war, and yeah, it was quite interesting how everything that happened. What is that OpenAI presented, and then I was looking at the Google I/O event, and I was like, oh my god, they really tried to ruin the day for Google, because especially when they were showing, the multimodal capacity, and being able to show the videos and being able to interact, like ask, can you tell me something about the video, and asking questions. So yeah, it was quite a thing what OpenAI did to Google, just presenting that the day before. Okay, I'm ready to share the screen.
Yeah.
And I guess we can start.
Yeah.
Okay. Just 1 second, and thank you everyone for your patience. And I think this, and please let me know if you can see my screen.
Yeah. I mean, you need to use share. There's a present button in StreamYard.
Yeah, that's what I'm trying to do, but since
Mhm.
this is a new laptop, it seems that
Okay. Then you
I need,
might have to give access. So there's
yes.
some.
Okay, so system preferences. If you can give me a minute, I will
Sure.
set it up. Right. I will need a couple of minutes, and because I need to restart Chrome, and I'll be
Sure.
right back. And thank you everyone again for the patience.
No worries.
All right.
We are back.
Okay, I think we're ready to go and I can share my screen now.
Yeah,
Excellent. Great.
you can see.
Okay. Well, thank you everyone, and thank you again for your patience. I'm super happy to be here with you today and to talk about Gemini and Vertex AI and this really cool SDK that we can use with Node.js in order to integrate um, these models and to interact with them. So we're going to cover a little bit of this, and I'm going to show you some code. I'm going to share a repo with you, and I'm going to do a small demo. Okay, so first of all, I will tell you a little bit about myself. My name is Patio Callahan. I'm originally from Venezuela, but I moved to Scotland. I live here. I have been living here for 7 years. I'm a technical leader at Charles River Laboratories. I'm also a Google developer expert in AI and machine learning. I'm an ambassador for the Google Women Tech Makers program, and I'm also running as an organizer GDG Glasgow. Tomorrow we are hosting our Google I/O standard event, so we're pretty excited about that. I'm also a Google Cloud Champion Innovator in AI and machine learning, and I run a code club at my local school. I teach teenagers how to code. We do a bunch of machine learning, which is super awesome. They're really brilliant. And if you want to get in touch with me, if you have any comments or do you have any kind of questions about this session, you can scan that QR code that you see over there. And yeah, let's start. Okay, so usually I do an introduction into what is generative AI, but because of timing, I'm going to skip that part. However, I will share with you some resources where you can go to and read more and learn more about generative AI. Then I'm going to talk to you about Google Cloud Vertex AI, which is an amazing platform for all of your machine learning, projects. I'm going to show you what is that you need to follow when you're running this workshop at home. You can follow the workshop at home, and I will share with you the repository, and on the README file there are all of the steps that you need to follow. And then by the end, we're going to have a look at the code and see how this works. All right, so let's start talking about Vertex AI. So like I said before, Vertex AI is a Google platform that allows you to work with machine learning, and it combines data science and machine learning workflows. And it's a really cool tool, a really cool platform to train and deploy your own projects, and allows also team collaboration. And you can, be able to use like a common tool set in all of the different areas that need to contribute in order to put into production these kind of applications. And another thing that I really like about Vertex AI is that it offers a bunch of different options that you can use depending on your level of expertise. So it doesn't matter if you're just starting into the world of machine learning in the cloud, there are options for you. So let's have a look at each of those. Okay, so first we have AutoML, and AutoML is really nice because you can find a way there to have a look and organize your data for the training. And using tabular data, you can organize images as well, text, video. So you can prepare all of your data and train these models without writing code or preparing, having to do like a very intensive process of preparing your data. Then we have the custom training, and of course, this is another level that allows you to. It gives you like a complete control over the training process, and you can with over there you can use, if you have a favorite, a preferred machine learning framework, let's say maybe PyTorch or TensorFlow, which is my favorite. You can use it there to write your own training code and You can do all of the tuning options and all of the things that it really allows you to have more flexibility into doing what you want to do into the very detail. Then after that, you can also find the model garden, which is also really, really nice. And over there, you will find a huge library of models that are available. You can find, obviously, the Google models. You can find the different versions that are available for Gemini. You can also find the different versions that you can use for Gemma, which is the family of open models. And then you can also find open source models like, for example, Llama from Meta. You can find Stable Diffusion. And not only LLM models, you can also find there other kind of machine learning models. Let's say, for example, for MediaPipe, if you want to use a model for hand gesture recognition, you can find it there as well. Or let's say sentiment analysis. So you go into the model garden and you just can like pick and choose what is that you need for your own project. Then, of course, we have the generative AI section of Vertex AI. As you know, generative AI, we can say that right now is the most popular field within artificial intelligence, and a lot of applications are being built around this kind of AI. So, of course, they are giving a bunch of a really good intense focus on generative AI. And again, you can have access there to all of the Google's LLMs. They have, as you might have seen at the beginning of this week, they are multimodal. You can work with text, with images, with speech, with code as well. So you can tune these models to meet your needs, and then you can deploy them to use on your own AI powered applications. So now I want to go through the whole generative AI workflow that you can follow within Vertex AI. And what I really want to show you is how, apart from all of the, let's say, technical things that you can do with the models and in this workflow, is also how you can integrate and how is integrated responsible AI in all of the all of the journey. So let's start with each of those. So first, we have obviously the prompt. The user is going to write the prompt, and there are different kinds of prompting techniques that you can use. So again, you just want to write into, using natural language. You want to query the prompt and wait for a response back. So there is this area called prompt engineering or prompt design, which what it wants to achieve is to have the best way to write these prompts in order to get the best answer that you can get back from the LLM. So there are several kinds of prompts. So for example, you might hear about the zero shot, which is like you can give it an example to the prompt and to the LLM, and it will like how it will return how it should return, or what is the type of answer that you're waiting back. Then you have, for example, few shot, and few shot, you're giving it several a few examples of what is the let's say the prompt that you are writing and what are you expecting to get as a result back. So you're kind of guiding the LLM into what is that you're expecting, or how is the kind of the format of the answer that you want to get back. And then you can also have a multi-turn, which is kind of a chat into how you interact with it. Okay, then we go into this is being sent right? And it gets to the responsible AI and safety let's say module. So what happens here is that that prompt is being analyzed in order to find, probably to find, let's say, a risk that, or to find content that you really don't want to allow into the workflow. So for example, and we're going to have a look at that into how you do it with the code, but maybe you want to avoid, for example, sexually explicit content or content that can be considered harassment and so on. So that goes into that module. And if it doesn't pass that, let's say, filter that you can play with it, then the workshop, like the workflow, is stopped. Like the LLM will reply back like, I cannot respond this because, I don't know, let's say that you ask, tell me how to build a bomb. So this safety, responsible AI and safety model will stop that, and the LLM will reply, I'm sorry, I cannot give an answer to this. So let's say that you pass that, the prompt passed that area, then it will go to the model, and the model will, process a prompt and get a response back. And of course, we also have the model customization, because you might want to do some tuning over that LLM depending on your use case. And then it goes back with the correct answer, and then it can go to the grounding service. So the grounding service is that sometimes you might need that the response that the model is giving back, it needs to be what is called grounded. And this is like the ability to connect the model, like the output of the model, to a verifiable source of information. Let's say a source of truth. So maybe it can be your own data, your own set of data. And this really allows it avoids, or help to avoid, that the model end up having hallucinations, especially if it's giving a response on over unknown topics. So it also gives like the model an access to new information. But again, this is optional. Then you can go to the citation check, and after the response is generated, Vertex AI will check whether citations need to be included with the response. And if there is let's say, a significant amount of text that is included in the response, then, and if this, if this significant amount of text that is included in the response comes from a particular source, then that source is added into the response as metadata. So that is really cool, because you can grab that and then present that as part of the response with the proper citation. And then again, we go again to the responsible AI and safety module, or let's say layer, and the response goes through these filters of security, just like we did at the beginning when the prompt went through this filter of security. And it checks again some thresholds that you can set for different kind of safety categories, and I'm going to show you and talk to you about those. And if the response is let's say valid, it will provide the response, and if not, it will go and say what I told you about. And then we have, it checks the output, and then it gives the response back, and everyone is happy. Okay, so this is basically the workflow that we follow with Vertex AI. And then again, what are the models that are available? Well, this slide is this deck of slides. I prepared them. I updated them like a couple of weeks ago, and probably I will need to update them again. And that is a problem of being a speaker in the AI field. It's like you always need to update all of the information like way quicker than you really expect. So yeah, we have Gemini, all of the models that are available for Gemini and Gemini Pro Vision. For Gemma, which I absolutely love, is the open models, um, for Google. So you can find Gemma, you can find Code Gemma, which is the one that is it helps you with the coding. And then there are additional models that are more varied. So for example, the Cody APIs, it helps to generate code. The text embedding, it allows you to generate vector embeddings for input test. We have a bunch of multimodals. Imagen, which is the text to image foundation model. MedLM, which is very domain specific. And this is for fine-tune for the healthcare industry. And there's a bunch more. Okay, so this is what I think is very important, because when we work with generative AI, we really need to be careful about safety and about responsible AI. And I think we don't discuss that as much as we should. So these are the safety attribute definitions that you can create or play with when you're working with the Vertex AI API. So you have hate speech, which is to block negative or harmful comments regarding identity or protected attributes like race or religion and so on. Harassment, it can block, bullying, malicious comments, and so on. Sexually explicit, dangerous content, like it, for example, I want to build a bomb. And then the next step will be set up what are the confidence score, which is the confidence score for each of the safety attributes that you might like to use. So that goes from 0.0 to 1.0, and that is like the likelihood that of the input, right, belonging to each of these categories. So it can go through all of those levels that you see on the screen, and because of time, I'm not going to go through all of them. And then we have the severity. And this is important. These are the thresholds. So you can play with those as well. So you can say, okay, I want to block, I don't want to block anything. It doesn't matter what is the probability that comes. It may be, it might identify, okay, this prompt has, harmful content. I will let it show anyways. Or you can like block everything. You can play with all of those levels. All right, so this is nice because you will be able to find in the documentation what are the libraries that are available for your particular programming language that you're working on. So in this case, we are going to have a look at the Node.js one, but you can have for Python, Java, C# and so on. So the cool thing is that you will find it on the repo and you will be able to start working with it. This is where you can find. I will share the slides later with you, or you can Google it. But you will be able to find the client and all the documentation for using the Vertex AI service over with a Node.js client. And these are the steps to set up the project. Again, usually I run this as a workshop, but because of timing, I will just show you all of the steps, and I will also show the repos so you can find it. Okay, so let me see if I can share, if I have the URL for the repo somewhere. If not, I will share it with you later. So let me see if I can over here. I will show the code and hopefully you can see it correctly. I'm gonna put it a little bit bigger. So what we do here is that we have to and we're working with Node, right? So I have to install the package for Vertex AI, and then I require that package. Then if you go to Google Cloud and you start using Vertex AI, you start a project, and again I will share the repo. That project will have an ID. Okay, so this is where you have to run to put that ID. Then you select the location, the closer location, depending on your geographic region. And then what we do is that we initialize an instance of Vertex AI with the options that I told you before, the project ID and the location. Then we can call, like we can set what is the model name. And in Vertex AI, again, you will see the different IDs per model. And I haven't updated the repo with the latest changes because here it refers specifically to Gemini Pro, but we can just call it model name, and you can use, Gemma. You can use any of the models that you would like to test. Then this is the part that I think is very important as well. So this is where we set the safety settings, right? So we say, okay, the category that we're going to work on is dangerous content. And the threshold that we want to set is block, medium, and above. So the ones that are, let's say, considered very, very dangerous. Then we're going to instantiate the model. So we have the options, which is the name of the model, our safety settings that we already set up here, and generation config. So we're saying, okay, the max output tokens, we're going to say 256. Then we are instantiating, like we have the generative model. We want to get the model with the options. And then we have this function. And what we're doing is that we're creating a function to start streaming the content that comes from we're going to query the API with the request, with the, let's say, the prompt, and we're going to get back the response. So for example, here, this doesn't have a proper UI. It's just all through the console, and we are kind of and again the latest. I will share the repo, and you will see that is updated. But right now we have like the question is hard coded, and then okay, we're asking what is the capital of Germany, and what it does then is that we are going to send the request, and we're going to wait for the stream back from the request. And what we're going to get back is the response, right? And if it doesn't work, if there any error, we catch it and we show it on the console. And by the end, we're just calling that function. So let's see it running. Where's my, here it is. So okay, I'm going to clear this here. Let me show the console here, hopefully. So if I run, put it a little bit bigger so you can see it. If I run this, it asks the capital of Germany is Berlin, and it sends the chunks with the whole response. So for example, if now I want to say something like, can you teach me how to build a bomb? And we run it again. Go over here. Where's my terminal? Okay. I can run this again. And as you can see, it says, I'm sorry, but I can't help you with that. Building a bomb is illegal and dangerous. So we're getting the safety response, and it's actually working as we requested to do it. So this is the, let me go over here to share the repo. This is the how the whole process works. So I know if there is time for you guys to ask questions before we wrap up because I think the time is over. So, while unlikely to need anything dangerous myself, how harm is calculated. So again, yes, it's calculated by these safety settings that are already available in Vertex AI. So it has a process where it calculates, depending on the prompt, what is the harm between zero point 0.0 and 1.0, and then you can set the threshold that allows you to say, okay, I want to filter up to this point, or I want to just let everyone, any kind of response to come back. Is there any other question that we might have around? If not, I will find here the show you where is the repo so you can go and play with it. So I will share this over here. Okay, so if you go to Patineta, I will share it on the chat, Google Vertex AI, you will see the repo with all of the steps so you can follow this code and you can play with it. And again, if you want to contribute with it, you can create a pull request. That will be great. Let me share this in the chat. And that's the repo. And again, if you have any questions or anything that you would like to ask me or share with me, I'm more than happy to connect with you. So thank you everyone for joining, and thank you, Santosh, for having me. I hope you have a great weekend.
Hey Patty, thank you again for your great talk. So as you mentioned, like AI is everywhere. Like good thing is, of course, they're building the safety parameters in the AI. It should be responsible. So hope people are actually building responsible things. They're not making bombs.
Yeah, exactly.
Fingers crossed. So thank you again for your time, Patty. And as I said, like don't disconnect. Just leave the StreamYard tab open, and you can leave. I mean, you don't need to sit on your machine. Just leave the tab open, so it will keep and watch in the recording tab. It will show when your upload is done.
All right, sure.
Yeah.
Thank you, everyone.
Thank you. Thank you. Bye bye. Hey, Alvin. Okay, let me just move on. Hey, Arvind, thanks again for joining. So, Nick, our next speaker is Arvind, and he'll be talking about understanding fine-tuning primal customized large language models. So, of course, so many AI talks as you have already seen in past, right? Google I/O, then OpenAI, and probably in future as well. So here also we are doing the same. We are trying to make sure you have enough knowledge to understand what's going to come or what happened. And Arvind is the best person to actually talk about LLMs. And thanks again, Arvind, for your time.
Thank you, Santosh, and thanks for accepting the talk. I think I did not have any anything to quickly think that okay I would get accepted, but then thanks for featuring. And
Yeah.
I have prepared something very basic. And like you said, AI is everywhere, but I would say generative AI is really interesting to me personally because I think I worked in the search space for more than 5 6 years and worked with the Elasticsearch community. So I think there's more to be done in this area, and then I'm quite excited to talk about all of these. Yeah,
So over to you. I'll just add your screen and yeah, go
definitely.
ahead.
So a bit of intro, and I want to do this talk today. Think a bit hutke, not in the usual way, having a presentation and stuff like that. So I'm Arvind, and I'm a developer advocate, developer builder, FOSS enthusiast, whatever you call. I like tinkering. I like playing with newer SDKs, newer APIs. So that's how it is. I run a newsletter, Dev Shorts, actually, and currently I work with a company called Fireworks, which is like a LLM inference company. If you don't understand any of these, LLM inference, I'll just demystify it in a bit. But of course, I think you might be hearing more of these in the coming days and more. It might also be overwhelming to you in a way. So we're trying to explain a sample concept here, not specifically anything else. So So yeah, I think like Fireworks is one company that I worked previously. So Libby, Elastic, Clean Lab, bunch of companies, some AI, some database. I'm quite excited to be here. And if you are interested to connect, I think like yeah, this is a QR code. We could connect on LinkedIn as well. So today's talk, the agenda is this, wherein I want to really cover about this interesting concept called fine tuning. You would have heard about large language models, and large language models to me are like just big, large math balls or math cubes of informations, and represented with a lot of vectors and interconnected with all the relationships and all semantic knowledge. And then when you ask a query, which is again a vector, and then it asks questions. But how do you like make sure that this model is adapted towards a newer thing, like say for example a newer news item, or a knowledge repo that has been created later point of time, and then how does it adapt? So fine tuning is one simple concept which helps does some sort of thing. So I'll explain more, a bit more detail into fine tuning, and then why fine tuning is important, what are the practical applications, and what are the challenges, and then a sample demo, and trying to do a production demo. I'll try to see, like if we could fine tune or showcase a llama actually, trying to do it very raw. So I kind of like have done a bit of like in the back previously some PyTorch work, but then I'm trying to do it like quite easy for product engineers and people to consume, not specifically for folks who are like say already into ML, have done ML ops and more of that. So maybe people would find it very basic, but then I'm trying to make it like simple. So what can you do with LLMs? Also, one other thing, like please keep your questions pouring. I'll take a look at it, and once we could I'll have definitely have more time for questions. But also, like I don't want to consume all the 30 minutes and then try to go quickly and showcase a notebook so that you have something, and I'll also share that with you so that you could also learn. So yeah, what can you do with LLMs? There are multiple things that you could do with large language models. I'm not just talking about GPT, but there are open source ones like Llama, Falcon. There are tons of open source models as well. Mistral, different models doing different, like different areas, playing at different areas. So like say building chatbots, very common, using retrieval augmented generation. I think Hemantika spoke about RAGs. I hope you would have seen the talk. If not, and then getting real-time updates via function calling, another interesting concept to me and very relevant to all of us who are building APIs. I think end of the day you would have some function, or like if you have worked in the serverless area, I think quite exciting to understand more, like you can ask a question and then it will calls an API, something like that. And then you have summarization or information extraction from a specific area, like say you give a blog information and then it asks it to like summarize, or like more interestingly, I think this is one of the early stumble areas for me as well, is like code generation, generating code when you're writing, just helping like a pair programming buddy. But all of this also like have a tinge, right? Fine tuning is also one thing that you could do with LLMs, trying to adopt, trying to play with the tonal quality of the large language model, like how the LLM should speak. So that's what let's go a bit deeper into the fine tuning, but these are many use cases. Each one can be a talk, can be a good concept for you to explain for like 2 to 3 hours in a session, but more can be done as well. So what is fine tuning? Like I say, for example, I don't know how many of you have really worked on ML deeply, but I also did not do it. I have only like built very small models, or like some scikit learn work, some pytorch work, but otherwise if you're looking at a large productionized model, like say a BERT, right? BERT, it's also a language model. Lot many people might not know, like until GPT and all, but then it's also a large language model. So if you're looking at something like a GPT or something, all of them are pre-trained models. So models which has some knowledge and it remembers something, and it is the graphs. Think of it like a bed first search, or like some sort of neural network, a tree that feeds and has a lot of matrices, or like a lot of knowledge that is retained with weights and biases, etc. It has learned from the pre-training knowledge. So what fine tuning specifically does is like you adjust that it to understand and learn from a specific custom data set that you have. Say for example, a newer thing, like for if there is specific floods or some sort of additional data, like I'm talking about a news item like floods, that is more real time, and there are some stats around it, and there's a good amount of information that is given. Or probably like take a newer event that has happened post the model has been pre-trained, and then you want to incorporate that sort of extra knowledge. I think it gets very interesting that the model will consume that form new layer at the end, and then it can remember and like compound the knowledge and deliver you better result. Most people, what they do is like they try to funnel the pipe, like say for example make the model speak in a specific language or a specific tune to a specific task, because it knows like you're making something more specialized from a generalized area. So that's what fine tuning basically is. There are many methods, like LoRa, there are Dora. I'm not going to math of it because it might get also boring. But I'm trying to explain you that there are various methods. Some freeze some parameters, some do fine tuning it a different approach. But what I'm trying to give you is a gist, and then quickly going to showcase some example. So why is fine tuning important? Like of course, like to adapt to domain specific knowledge or task understanding. Say for example, if you are building a insurance based customer service bot, and you are using something like Llama, which is very common, like which looks like, or a GPT, which like you add a chat layer, it looks like chat GPT, right? But you want to make sure that all the insurance terms, say for example in India you have IRDAI, or in Netherlands or some other country you have different regulatory authorities for the insurance, and then if they have specific terminology like say VOG in Dutch or some other places, and then you people ask that question, right? What is your credit rating? And then it should be able to kind of like give out information with such acronyms and everything, and that way you could improve, that way you could build a lot of things. So improve tone or quality, if there are some people who want the model to specify or speak in a specific language, so that's also one good area to look at in specific way. What are some practical applications? Like again, I think question and answering seems to be very popular. Domain specific chatbots, yes, but the data set is less. Code generation, very popular. Most of the large language models that you see are like focused on code generation tasks. Like say for example, ton of people who fine tune Llama for code. In fact, Facebook itself or Meta itself does this called Code Llama. They released Code Llama. Then there is like Star Coder, DeepSeek. There are bunch of models which are more focused on code generation, like fine tuning it itself. Or you could take a model and fine tune it with a SQL data set. Like say you give all the different types of, like say, 1,000 or 2,000 or 5,000 or 10,000 SQL commands, and then you kind of like fine tune the model, and it starts to understand what SQL is. And then whenever you ask a question in natural language, it can give out a SQL command out of it, auto generated SQL command based on the knowledge that it has learned. So that's something. It's not extrapolation, it's like learning and mimicking and trying to give. So there's also an edge case that while you are making it learn, the chances that it could also hallucinate and try to make up things, because in the past knowledge it would have crunched a lot of knowledge from W3 schools everywhere, like anywhere and everywhere. The common crawl data set that is widely used in pre-training all of this data, all of these large language models. Yeah, I think like I said, to connect to the point, like what are the challenges in fine tuning? The challenges in fine tuning is like good quality data. A lot many companies, open source projects are now coming up in labeling, curating good quality data. But the biggest challenge is like data itself. And there's a lot that needs to be done for any organization, not just hobbyists or indie developers, or like people working in one company. It's for every organization. The data is definitely in different formats, like even though it's structured, unstructured, but it is not ready for you could fine tune it. It's not automated at scale. Like you could not take up a petabyte, or like at least even a GB of data, 1,000 samples in Excel sheet, and you can't label it, right? There are companies who use this to do it, by the way. There's something called Scale AI. I think they use humans to kind of like help label the data accurately. But there are open source projects like Clean Lab, which helps you to curate this data in much better manner. There are people who are using LLMs to do this itself. Like you use a large language model to do a quality check It's called LLM as a judge or something. This company called Refuel, which does this with different models as well. So there are many methods, but then data quality is prime, and it's really really huge. And second, and more importantly, is like, costs come into play as well. How big you take the model, and then, how do you like fine tune it. Like, say for example, there's one model in mixture of experts, like, recently Mistral has released to fine tune something at that stage. I don't know what are the results, and what is something that you are expecting. How large is the data? How many days it would take? It's as good as like sometimes pre-training, right? It might cost like $1,000. And not it might be simple for a large bank, but then it can also scale up uh, to that cost, like, petabytes of data. It'll really look big. So there are efficient methods that are developed for reducing the cost itself, but it remains a one significant problem. And operational reasons as well, like, challenges in fine tuning is like, the tuning time, like how much time it would take. Like, say would it take days? Say for example, I submitted a job before coming to the conference, and I was worried that it would not complete in time. Luckily it took 20 minutes or something for fine tuning, like, I mean, taking 15,000 rows of data. So relatively okay, but then it might be more as well. Say you need to use more GPUs, like if you're using H100s or like something like that. If you're using 4090 or that sort of a okayish GPU, still bigger or costlier. But then GPU crunch and GPU problem will also be there, and maintaining, operationalizing these GPUs with the respective hardware related software like base command manager and a lot of that would also like take away different problems as well. So these are like huge challenges, very important, especially the data quality one. There could be again one deep dive that you could do, which will take 40-45 minutes to explain why it's so important, how you could do it, what are the various methods academically to look at it. So there are more research happening in that area itself, called data centric AI, using data to improve the AI itself. So very interesting paradigm to look at. So yeah, I think I'm trying to time it, and then trying to look at the watch to figure out and come to this place. So I'll quickly reshare my screen and share a notebook, because it's important. And maybe like, let me share. So what I did was, maybe Santosh, if you could reshare the screen. Yeah, fantastic. So what I did was, like, I have a one layer simple neural network that you could use, and that you could potentially kind of like build even by yourself and learn. So this is just about learning the fine tuning and nothing more. I also like use the libraries to import in and then did all the basic stuff. Try to do as much as possible. So if you what we're trying to do here is take a MNIST dataset. MNIST is a OCR dataset, optical, uh, optical recognition. Like, say for example, you have numbers that are written, like say 0, 1, 2, 3, handwritten, and each person could write numbers in a different format. So you kind of like have numbers from 0 to 9, and then these are the scraping, or like the cropped up images of each number. And those numbers are trained, like these are classified as like, this is 0 and this is 7, and you're training a specific model with 0 to 7, and then like, you are trying to retrain it with like, 7 and 8. So actually I have got the MNIST data set here. I've copied it. I took a slice of it. So now we are creating a training data set, like say for example 0 to 7 and 8 to 9, and then test data set. Of course, you need to test whether the training worked or not, etc. So I'm not sure even if we could complete this particular training. I have Collab Pro, which is connected to a high RAM GPU, but we'll see if we could complete or not. So what we're trying to do is like very simple one layer neural network. This is not even a language model or something. Very simple, easy to do things, and see how in the end, like, the parameters have differentiated what fine tuning did to the learning. So that's what we are trying to understand. So we have created a model, one instance of model, and then I'm not even going deeper into each one of them, and they are like very common simple getting started examples or something like that. And yeah, so it will take some time to like train this. I have put 5. I should have done like 2 or 3, but it also depends, like your loss varies and everything varies as per your thing. So I took in each step, I think, around, there are like 754 in a batch, and then I'm taking, like, each step like 100 images and then training it. So that's how it will progress. So the first training was complete, and then now we'll test the model, and on the 10,000 images, like, how does the accuracy will play. So let us quickly do it. We did not fine tune it, we just created the first version of the model. And then accuracy of the model on test images, like this test images, it has not seen. We have trained it with like the train images, now we are testing it. So yeah, I think that's good. It hasn't seen. You also see, I think I want to point out, we trained it with 0 to 7, and we tested it with 0 to 7. Then it saw 97% of information. Like, okay, yeah, it is able to predict 97% of the images, right? And then we asked with, like, did you see 8 and 9 types images, and can you find what it is? And it did not even predict one, so it's 0%. So you know that it is not. Now we'll apply LoRa, which is like low rank adaptation method. It is a method wherein, say, for example, if you have a neural network which is like, which has multiple nodes and with multiple layers, and what LoRa does is, like, it's a made specific method which saves some sort of cost and also, like, improves some efficiency. It actually freezes all the parameters, like, all the, think of it, all the numbers and matrices and everything, that is the knowledge that is retained in the model, and only allows fine tuning of the last layer, and then and adds a new layer to it. So that's what LoRa does. And again, I'm not really deeply going into each one of these. And so we create a fresh one layer neural network. We are copying that model weights and everything here, simply, and then we are creating a new neural network. And yeah, we're creating a model here, same thing copied, and nothing has changed. And we initialize the LoRa specific weight, so that, like, it's normal, so we don't get fudged numbers or problems. Yeah, copy the weights from the original one. And yeah, like I said, freeze the non-LoRa parameters, and loss function and optimizer, and then start the training for 8 to 9, right? We are not again doing the old training. We're trying to train with the new one. So again, see the loss, I think it is reducing. And then we will also try this one with the newer one as well. Test the model with 8 to 9 classes, not 0 to 7. So it says 91%. And then test the model with 0 to 7, it should retain the knowledge. So ideally it should give good amount of information. So yeah, I think it was okay. It retained some information. We'll also, like, load a sample image and see if we could infer if it could deliver a result. So for example, and run this through the LoRa model, and we'll see how the result would look like. So the one layer neural network actually predicted. We also have everything mixed up in that one, right? I think 8, 9, and everything. So predicted for actual 9, and then here it matched most of the everything that we have given. It was able to predict something. So you could also compare. This is like a vanity metric, but you could also compare, like, say, what are the parameters in the each difference in the each model. So there is some difference, like, say, for example, it is like having uh, 101K, and then it has some more in a specific manner. So in the crux, LoRa helps in a way to understand or adapt to newer knowledge. So that's what we are establishing here. It's a very, very basic example to look at everything. I hope you're all with me. And then I think, like, there is some more time. What I'll do is, like, I'll go back and start sharing my screen, uh, so that, like, maybe we'll learn some more things as well. A production grade example, mainly. So let me take a look at. I don't think I have time to cover everything, but what I can show you is a fine-tuned model, and or probably I'll show you the documentation itself. So that is much easier for us to go and look at it itself. So let me share the screen. of a fine-tuned model. Okay. So like I said, you could fine tune an open source model. So this is like a documentation for it. We don't have time to create everything and do everything. So for example, what happens in a fine tuning is like how we picked up the MNIST data set. You could pick up a data set that is on the Hugging Face. Like say you could pick up something like this. Let me showcase. Like Databricks Dolly 15K is a data set that is Databricks has released, and it internally made up from their own employees and all. And Dolly is a very popular data set. They used it in their own model creation, but also like there are various variants of Dolly itself that are more popular in creating the fine tuning models. So I'm not like going deeper into each one of this area in the interest of time, so I want to take some questions as well. So but otherwise, in production what happens is like you pick up one of this model which is already there and deployed, and what you do is like prepare the data in a specific manner. This is very important because you want to have the data labeled in a specific manner. Say for example, this is like a format it's called instruct tuning. You're trying to tell, say, when was Tomoyuki Komorida born, and then you are telling that context is this, and you are also giving more information on like response should be this thing. This is how you want to respond. And category is closed QA. You have these three parameters. It's like an instruction tuning, and you create a job. It might vary for each platform to platform. It might vary for each open source system, like the prompt template and everything. But end of the day, what you're doing is like you're doing a fine tuning with one of these methods, preferably LoRa. Most people use LoRa. It's a very popular, again, the paper is very popular, and you could also read about it. And then you eventually, like say for example, create a job, and with specific template that we have in the the instruction tuning. You're training with this particular thing. You probably use a base model or something like this, or you could use something like llama. And then you eventually kind of like create like create a fine tuning job, and then deploy it for inference end of the day on production. So end of the day, you are working it like an AWS EC2 instance, or like AWS Lambda type of service, and you are actually deploying this model using the model that's already deployed, because this all of these models are like in GBs, in like more 100 GB, 200 GB, and you need a GPU which is having certain amount of VRAM to hold all of this and run this, and that's why it is more costlier as well. And you might need credits. The good part is, if you are using any of these platforms, they give you good amount of credits. If you are using something like OpenAI, I think they charge money for the number of tokens you use for fine tuning. Like say based on the data set, you are using like say 1 million tokens, maybe they would charge like $2 to $3. It depends for tuning a model like GPT-4. But you could also use your own laptop, your own tools like Olama and all, but they don't have fine tuning. And you also like have, if you have MacBook, still you have some benefit. But then the MLX and the fine tuning system is like not so well done from a developer experience point of view. So you could use one of these platforms, and then build, deploy, and train it on, tinker around, and figure out what you really need. Fine tuning is really helpful. It helps you to adapt to new knowledge. In fact, actually, if you are building a RAG and you are using a customized fine tuning, if model, and using a vector store like say Quadrant or SerialDB or one of these systems to augment the data, it works really well. The knowledge compounds and the gains also compounded. So there are, like I said, there are more parameters and everything that can be fine tuned, or like that can be changed. You could track progress more. For each platform it might differ slightly, but end of the day, this is how it is done. Whatever I shown in the code, it more or less is very similar to the here as well. So I have fine tuned a model, and I have like kind of maybe I can show my screen a bit for a while. And I have a model that is fine tuned on the same thing, and I've submitted, and this model is readily available for inference. And it's a add-on that goes on with llama. And yeah, I can showcase. I think I'm doing the same thing. So Mm. Yeah, maybe this would work. So yeah, I fine-tuned this model just before the session, and then you have more information about it. So yeah, I think that's it for me. And then I think we have 3 minutes to question. It's a short session, I know. And yeah, if you have any questions or uh, happy to answer.
Yeah, Arvind, thanks again for this great talk. We don't have any questions, but in just in case if there are any, you can always reach out to Arvind on Twitter. And
Sure.
yeah, so thanks again for your time, Arvind.
Thank you, Santosh. Nice to be here.
Yeah,
Bye.
thank you. Bye bye. Yeah, everyone. So we will be on break now. We'll be back at 8 p.m. and then we will have Sonam talking about uh, talking about her talk on use Rust power use Rust to power Python application. So if you are interested in learning like how you can use Rust inside Python, just do join this talk at 8 p.m. and see you later. And meanwhile, you can we have some coupons to share. So in case you want to improve your knowledge in Angular, there is 50% discount by simplified courses. Brett, who is an amazing instructor. There is also a coupon code for InfoQ Summit Munich, which will give you 35% discount, and currently they have the early bird discount as well. So you will get 35% on top of early bird discount. We also have 45% discount by Manning publication. So in case you want to buy any book by Manning publication, just go ahead and use the promo code which is available in the bar below. So you can see the uh, ticker which is there. And don't forget to join our closing note. We will have some ebooks to give for free. So we have some books from Pack publication. You can also get a chance to win 2 physical copies of your choice, like whichever book you want. And there are few ebooks which will be available as well. And then there are 5 ebooks from Tom Strawson for his new enterprise book, Angular Enterprise book. So do join for our closing note. And this will happen at 9:35 p.m. CT.
Okay, so hey everyone, welcome back to the TIL conference. I hope you enjoyed your break and you have your meal as well. So, without wasting much of our time, let's invite our next speaker to the stage, Sonam and her colleague. They will be talking about how you can use Rust to power Python application.
So may
Hey
I share
Sonam,
the
welcome to the TIL conference.
hey, thank you so much. Uh, so shall I start presenting?
Yeah, sure. You can just introduce yourself and let's get started.
Yeah, thank you. Uh, so I'm so happy to be here, right? So let's begin about the presentation. I think you can see my screen now.
Yep, it should be visible by now.
Yeah, so the topic for today is how we can use Rust to power Python application, right? One thing is very clear, Python is quite slow when it comes to tasks like, that it needs multi-threading and things like, heavy lifting things. So how do we enhance, how do we, enable Python with Rust? So, hey everyone, I'm Sonam and I'm the co-creator of Starlight and maintainer of Embed Anything. And I worked at Quadrant, Raza, and Sama Technologies. I also published a paper at ASL Anthology. And I love to go for hiking and play chess. So before going on to the presentation, I'd just like to show you a demo. So if you are able to see my demo, right, Manish?
Yep, it's
Thank
visible.
you. Thank you. So in this demo, you'll see the comparison of the performance of embed anything versus if we did the same task with same PDFs in Python. So what we are basically trying to do here is create embedding. So I just did Python and it came, right? It took 0.7 seconds. Now the same task I'm doing with simple Python, and it's gonna take time. Some more time, and we need to wait some. Ultimately, I think it will happen. Yes. So now we got. So with the with the simple comparison, you can understand the difference between how much robust embed anything is, especially regarding the memory, the speed. So how did we achieve this, right? How did we achieve this kind of 40x speed for extraction of PDFs, chunking, and then building these embeddings? So yeah, let's start the presentation. Why you should use embed anything. Embed anything is specially designed to enhance the speed, memory management, and minimalist dependency. What that means is if you use embed anything for creating these embeddings, you do not need libtorch, which is basically 1.2 gigabytes if you're using transformer library, right? And this is made happen with the use of Candle, which is also built by Hugging Face. So basically what you do, you have a Hugging Face sentence transformer, which you basically use in Python, but you can also use with Candle in Rust using embed anything. It also is doesn't go into global interpreter lock, which you can understand is a huge technical debt in a long time with Python. So these are the kind of offerings of embed anything to build your robust pipeline to build this local or multi-model embeddings using our open source library. So what does basically we do, right? So we do semantic search, right? We do semantic search for context and intent. So basically there are two kinds of search. There's keyword search and there's semantic search. So semantic search basically has its meaning intact. And we do also multi-modal search. So basically multi-modal means different modalities. That means audio, images, video files, and different kind of types as well, right? So we also do .pdf, .md, .txt, etc. Okay, so one of the best way is to enhance this with using vector database. So vector database basically acts as the infrastructure to store these embeddings, right? From these unstructured sources, from these different modalities, from these unstructured sources and different modalities, and storing, updating, and retrieving. So we also have our own RAG pipeline built with embed anything, and you can basically power your RAG pipeline with Rust using embed anything as well. Okay, so how do we go towards multimodality, right? Because I mean, text is fine, but what's better is to how one of the best use cases of generative AI is, I guess, connecting text with images or video generation. So how that is achieved?
So that is achieved basically with contrastive language image retraining, or that is CLIF that we are using, which basically you know connects text with images with similarity, and then training it, the encoders of images and text with the whichever describes the best. Suppose there's an image of a puppy, so we find the text which best describes that image, and we try to make the encoding such that these images are best described with the text, right? So this is CLIP, which is basically a training method of these multimodal encodings. So basically, how do we bind Python over Rust, right? So we are using PyO3 bindings with Maturi. So what basically PyO3 does is it calls Rust from Python, and Maturin basically interacts with both the projects, right? So Maturin starts working once you have enhanced it inside cargo.toml, and PyO3 basically has a Rust binding for PyO3, so for Python, and includes all the native creation of Python extension modules like PyModule and PyFunction. So basically what you do is in src file, you add these PyFunctions, which are basically made in Rust, and then you register these PyFunctions in the PyModule. If you want to see the repository is available here at Starlight Search, embed anything. One second, we have different examples. If you want to use RAG pipeline, if you want to use Python, we have bird.py. If you want to just go ahead with Rust, then you can also use .rs examples. Yeah, we also have our image search directly. So if you want to have this image search, if you have this directory of images of cats, dogs, different objects, and you want to search it with a query, right? So what do we have to do is embed text separately with the same clip model, and embed this image as well, and then find the similarity between the two, and then it can directly go ahead and search. Maybe we can have this demo as well here if you wanna see some different searches, right? Where so our embed anything is downloaded here, and then it can start working. Photo of a dog, suppose. Search here. So we have these test files over here for clip, where you have different pets images. Yeah, and I would like to pass on the mic to Akshay for how comparison of Python performance and Rust. Meanwhile, if you have any comments regarding it, you can go ahead. If you have any question. Hello.
Hey, yeah, looks like you explained very well. People don't have any questions as well.
Yeah, so I'll like to call Akshay for comparison of Rust and Python. Thank you.
Yeah, Uh, yeah, Sonam, should I go ahead?
Yeah.
Yeah, so I think, yeah, Mike, like Sonam explained, so we have been building embed anything for quite a while. So there are a lot of engineering aspects of what goes into creating such a pipeline, especially because there isn't really a framework built in Rust to like a full-fledged framework in Rust like this, like Transformer, there's PyTorch, is available with Python, but so that's what I and Sonam have been building. So I co-created Starlight and Embed Anything with Sonam, and I am also a lead of AI at Serpentine AI, which is a AI research lab at TU Eindhoven in the Netherlands. And I was a co-founder of a startup back in India, Fabits. So why are we making it so complex? Why there is already things built in Python.
Akshay,
So
do you have
yeah.
are you presenting?
Oh yeah, I am presenting. It's not
No,
visible.
it's not visible. No.
Oh, just a second.
Yeah.
It's there now.
Oh, 1 second. I just stopped.
I
One
think you
second.
removed it. Can you share your screen again?
Yeah, I am sharing. Uh, is it visible now?
Just press the present now, Akshay.
Yeah, I am presenting. Yeah, is it visible now?
Yeah, just a second. Let me add it to the stage.
Yeah.
Okay, it's visible now.
Yeah, so as I was saying, why are we taking such a complex route? I mean, everyone knows Rust is a little hard and not really, I mean, it is developer friendly, but there's a very steep learning curve. So why are we like doing this? So first we'll see how it differs from the existing tooling that is there with Python. So some of the advantages with Rust, like so Sonam explained, I'll dive a little bit deeper into this. So Rust, it's like the main USP that you will see, which Rust also boasts, is that it is memory safe, and most of all the errors are during the compile time. As many people who have used Python would have faced a lot of runtime errors. So the compiler isn't really helping you out as much. It can tell you whether a variable is not declared or something, but it cannot really uh, tell you about runtime errors. About in Rust specific, in Python specifically, you can just convert a variable that was assigned a string directly into an integer at any point of time. So which is bad for the runtime. It's good to prototype very fast, but it's bad as a developer or putting it out in production. So that's where Rust comes in with its memory safety. It really forces you to use the best practices as a developer to create a very robust application. And this is on the kind of like the syntax level and the compiler level. But if you dive little deeper into the kind of applications that you can create with Rust are also very vast, because it allows you to do concurrency and multi-threading right out of the box. So in Python, you can do some workarounds and get something running, but you will never achieve a performance in terms of multi-threading that you can achieve with Rust. And this is right out of the box that Rust provides you. And also similar to pip, you have something called cargo, which is a package manager for Rust, and it also comes with a lot of syntax checking, and it comes with your cleanup of your repository. There are a lot of There's cargo clippy, which goes and finds faults in your whole code base and also fixes them automatically. So there's this powerful tooling that's built right in. But Rust is kind of hard to learn. The ecosystem is not that large, so you don't get all the libraries. You might have to write things on your own at some point of time if you're really getting into complicated things, but it pays off in the long run. So I was talking about multi-threading. So why is multi-threading important for the application that we are building? So I'm just showing one of the example over here. So creating embeddings is not a very simple or a very less computational task. takes a lot out of the processes that you have. That's why you see companies trying to make this as optimal as possible, and that's where Rust kind of comes in and helps out in the computational aspect as well. So the main two places where we are using the power of Rust is kind of in the parsing. So as the name embed anything suggests, so what we are basically doing is being able to embed any kind of a document, and one of the documents is a PDF, and PDFs are not something that are very easy to parse. So if someone has worked with PDF, you will know that they come with a lot of overhead. You cannot just read text out of them like you would out of a markdown or a text file. So there is a lot of computational overhead regarding parsing a PDF, but Rust makes it easier. So we are using multi-threading to parse multiple documents at the same time, so that they can be converted into text chunks. So if you run this in Rust, so we took the in this example I have taken the attention is all you need paper, which is about 8 pages of PDF, a little over 8 pages of PDF. So the a Rust-based program can extract text and even chunk it in almost 1.0.17 seconds, and Python takes almost 3 to 4 times longer time in this aspect. And the second computationally heavy task is the embedding itself. So this is something that we are using Candle for, but it uses a similar thing where we put in all the text chunks at once, and it moves it across all your CPU cores, and you get the embeddings out. And the best part about Rust is it supports most of the accelerators out there, so GPU accelerators as well as CPU accelerators. So you can get almost 2 to 3 times speed up regarding embedding by using a hardware accelerator like Intel MKL or a GPU accelerator like CUDA. So another thing that Rust helps developers, or which is something not possible in Python, but it is possible in some cases now. So you can do a lot of async programming in Rust, and Rust is kind of optimized for doing this at least in the latest versions. So why do we need to do async in case of creating embeddings? So if you look at the pipeline which is synchronous, so the synchronous pipeline that I've shown here right now, so you basically take a PDF, you extract all the text out of it, and once you have extracted all the text out of it, you start splitting it. Once you have split it completely, you get the embeddings, and then can use the embeddings for downstream tasks like the similarity search which Sonam just showed you. But what are the problems with this? The downstream task has to wait for all the text to be extracted from all the documents. Everything has to be split, then every embedding. So you cannot start generating your results until all this upstream processes are done. This can become a bottleneck, and it's something that is not desirable for applications which have such bottlenecks. So for example, here getting the embeddings is quite a bottleneck. So this is where asynchronous pipeline comes in, and we can use. There are multiple libraries in Rust which you can use. So there's a native standard library for async. You can use futures and async, and but the most prevalent and which we use is the Tokyo async library. So what this does is basically you stream through you create a stream of data that goes through the pipeline, and so you have the text of page one, let's say, going through. It splits up, you get the embeddings, and then get the downstream task done. But while the embeddings are being created, you are extracting text of page two as well. So this works kind of like multi-threading along with asynchronous programming. So this makes it more. I mean, even if you're using a single worker, this is much efficient because you don't have to wait for all the text splitting and your extraction to be done before you go for the downstream time. You can start getting results for your downstream tasks even while the extraction is happening. So this is very good if you have a lot of documents and you want to start classifying them online. So I have mentioned Candle a few times before, so what I just want to motivate some of you to start using this very nascent library. I would say this is not very old or very well established compared to PyTorch, but it has a good future in my opinion. One is because Hugging Face, which is one of the biggest AI platforms, is invested in this, and they are someone who is growing this, and they're growing it very passionately. And what it mainly does is it removes the dependency of LibTorch, which has become more of a legacy, and there's a lot of bloat already there in that. Which so you need to ship almost a 1 GB of packages if you want to deploy a LibTorch based application, which is not really a good thing. And Candle comes with almost like 100 to 200 MB package, so it's good for like deploying on a cluster, and it's overall very lightweight and works very well. So it's a completely uh, ground up written in Rust, and something and it comes with GPU and CPU accelerators, as I showed you just now. And already there's a lot of models that you can just plug in. So you can even use it for LLMs like Mistral. You can use it for Gemma, and you can just plug in this, and you get a very efficient inference pipeline, and you can even train your own model in PyTorch, but you can deploy it in Candle as well. So, but one of the downsides is that it doesn't have such a documentation because it's a very nascent project, but a lot of work is being done on this already. Yeah. So that's it from my side. I hope I have motivated you to start using Rust a bit, even to power your Python applications, because at the end, Python is something which is easy to distribute and easy for people to work with. So, but there are ways you can supercharge your Python applications with Rust, and we have shown that with Embed Anything. Yeah. So, if there are any questions, I would love to have them.
So that was a great talk. And if you have any questions, you can just ask Akshen. Looks like you explained the concept very clearly. So
All right. Sure. Yeah.
thanks a lot, Akshay and Sodam, for your wonderful talks and enlightening us on the topic of Rust as well. So yeah, thanks a lot for
Thank you.
your presenting it. See ya. Bye.
Thank you. See you.
Okay, so it's the last talk for AIML track for TIL conference. So, and the speaker is also a special one. So, without wasting much of our time, let's welcome Mihai on the stage. Mihai will be speaking on the topic end-to-end secure ML deployments. So, hey Mihai, welcome to TIL conference. How are you doing?
Hello, thank you for having me. Can you see my slides?
Yep, they are visible. Let me add them to the stage.
Okay, perfect.
Okay, awesome. So, yeah, I will leave the stage to you. You can introduce yourself, and the stage is all yours.
Perfect. Thank you very much. Hello, everyone. I am Mihai Marusak from Google. I am leading Google's supply chain efforts for ML. And I will talk to you about how we can secure the ML development from the data all the way to deploying the model in production. So let's begin. In this talk, I will talk about AI, but I will also use ML. So you can hear AI or you can hear ML for the purposes of this talk, even though they are different in general. Let's assume that whenever you hear AI or whenever you hear ML, they mean the same thing. And the other part of this introduction, we contrast AI and ML versus traditional software. These two fields have some stuff that in common and some stuff that is not common. And we will start with the common parts regarding security, and then we will look at the parts that are different. So as part of the common parts, if we look back at the history of how AI has been developed or how the traditional software has been developed, we see that they are kind of parallel. So both traditional software and AI first started as hobby, as research. People that have more time to tinker with computers, they experimented, they released new small products that solved some of their problems. After a while, both in traditional software and in AI, these technologies became commercial. There were companies, startup created to sell this, and so on. And after a while longer, this became commodity. People everywhere started using them. So for example, in traditional software, everyone started having a PC. You no longer needed to be in a big company to access a mainframe. The same now happens with large language models. Everyone can now download Llama and use it on their computer. However, this parallel is also on the bad side. As progress of these technologies become more and more mainstream, we also got more and more exploits, more and more security incidents, more and more hackers. And the difference between traditional software and AI is that in the ML field, all of this history is compressed over the last few years compared to traditional software that started like in the 50s, 60s. So we are repeating the same history, but at an accelerated pace. And the downside of a compromise is even more severe. It can cost a lot, it can leak a lot of user data, it can cost a lot of damage. So this is why we will need to invest into security for AI. And let's see what is at the confluence of these two words, security and AI. We can have security from AI. Basically, here we want to protect users from harm that is created by AI. Or we can have security via AI. We can use AI to increase the security in other products. For example, we could use LLMs to generate fast targets, such that then we can discover vulnerabilities in other products and then improve their security stance. And then we can do security for AI, where we would apply concepts from security to the fields of AI. And for this talk, we are focusing on this one. We are going to see how we can adapt concepts from the supply chain security of traditional software to the AI world. But before going there, let's think about why do we need security for AI? Because if you generalize very fast, you can say an AI model is just a bunch of numbers and linear algebra. There is nothing about security in there. However, this is a complete wrong statement because we have seen a lot of experimental research that you can build an evil model where you can hide malware inside the neural network. Or you could build a GPT trained on 4chan, and now it will behave in a bad way. Or there was another article last year, you can poison ChatGPT to spread fake news. And even if you don't look at what the neural model does, the format where you save the model is vulnerable. Most machine learning formats, most machine learning models use a vulnerable format, use Pickle. And Pickle is very fickle, it's very insecure, it can be easily exploited. And this was actually a problem. Last year, 38 terabytes of data were exposed. And inside this huge bucket, there were a lot of data from Microsoft AI researchers, including models, and a lot of these models were using Pickle. So now, as part of this incident, there is no way to determine if any of those models have been overwritten, had malware ingested into them, had been changed to perform badly. So this is why we will need to invest into security for AI. Actually, the problem is even worse. We are starting to see AI and LLMs deployed into a lot of applications that in general used to be traditional software. So we see AI deployed into coding assistants like GitHub Copilot or Cody. We see AI being developed into applications that can go from a prototype, from a description of what you want to build to a prototype in just a few minutes. You describe with your prompt, I want to build an application that does this and that and that. Wait a little, get some demo. You can adapt the prompt, and after a while, you can get a full application that you can deploy to users. If you have some compromise in there that you don't discover, then the application that you deploy to users is going to be impacted. Even worse, we see AI being used in package managers used in high-performance computing systems. So for example, SPAC, started using AI to determine to resolve package resolutions at pip install time. If that AI gets compromised, you could compromise systems used for high performance computing for NASA and so on. So we see a clear need that we need to invest into security. And now let's look at an example of what an attacker can do to exploit models on Kaggle. I pick Kaggle as an example. So let's say now I wear a malware deployment developer hat. And I built two models. I built an evil model, and let's say I also want to deploy GPT-4chan. I can upload these models to Kaggle, and in the model card, I give them nice names. I say that the evil model is actually a model that can detect malware, and GPT-4chan is a friendly chatbot. You can chat with it whenever you want, and so on. And then all I have to do is wait until users download the model and then exploit them. Of course, users are not going to download models that have names as evil model or GPT-4chan, but that's easy to fix. I can just change the name. So now there is a nice model, and there is the GPT-4 friend. So probably some users will just download it. So the general idea here is that looking at just the name of the model and at the model card, that's not enough. The model is not publicly attributable to the user that uploaded them. So there is no way to go from a model to the user to see what their reputation is, to see if they are legitimate or malware developers. So as a conclusion, is we need to protect the ML supply chain. If we don't do that, we are going to have compromises in the future when models that have malware in them or are malicious are getting to be used by users. Okay, so what is this ML supply chain? Looking at how ML is developed, we see three separate stages. The first stage is looking at data, gathering enough data, analyzing data, filtering data, making data in the shape that you can use for your model, and then training the model. The second stage, which in general is given to another team at companies, is publishing the model. So you can take the model that has been trained, put it into a model hub, so in Kaggle, in Hugging Face, and so on. And finally, the third stage, which again can be at a separate team, is taking the model from the model hub and deploying it into an application. So now you have an AI-powered application that will either send the request over the internet to a model or will have the model embedded inside the application. So for example, you could have a mobile application that uses an embedded model inside the phone. Okay, so now let's look into deeper details on how a model gets developed. So let's say there is this ML developer, and they want to build a simple model. What they will do, they will need to collect some data sets. So let's say CR10. They will need to pick a training framework, let's say TensorFlow, and then they would write some code to split the data set into training set and test set and so on. So basically start training the model. Of course, they also need to define the model architecture. So let's say a simple convolutional neural network, and then combine all of these pieces together and run the training process to obtain a model at the end, after several hours or several days, depending on what model you want to train. Once this model is trained, the model gets deployed to a model hub, Kaggle, Hugging Face, and so on, or maybe internal hubs. And then some other team would download the model from there and deploy it in production, basically ingest it into a model into ML-powered application. So this is a general idea of what the ML supply chain looks like. And if we look back at the parallel with traditional software, we see that we have the exact same diagram for traditional software. We have a developer that writes code in a repository, takes other dependencies and builds an artifact together, which then gets released. And then at the production side, somebody downloads this artifact and deploys it such that users can use it. The parallel, so we can say that models, building ML models is almost similar as building software artifacts. I say almost similar because, as we'll see later, there are a few more risks associated with ML development, and we'll talk about them a little bit later. Speaking of risks, the same risks that we see on the supply chain for traditional software, so we can submit bad code, we can have a dependency with vulnerability, the source control itself can be compromised, or the build system can be compromised. This is the SolarWinds attack. Or even the package manager can be compromised, or when you download the artifact, you download something wrong. All of these risks, they also map to the ML pipeline. So the ML developer can submit a bad code, can accidentally write code that during training also leaks the data that the model is looking at during training. Or you can use a data set that has poison data. Or if you are using pre-trained models, before using them in production, you modify the weights. Or you can have a framework, an ML framework like TensorFlow and so on, that has a vulnerability. We still have the risk of compromising the source control. You could also compromise the training process in case you can get access to the training environment. The model storage can be compromised. So this is the example where the 38 terabytes of data from Microsoft got released. And in the end, you can trick users, applications to use a bad model. And then you can exploit the model misprediction. So this would be like the supply chain for ML, except the supply chain is a little bit more complicated. So let's look again at how we train a model. In general, we start with the model source and the ML framework, but we also need some data sets. And for larger models, so like LLMs and so on, we actually do more steps. Once we train a model on some data sets, we put it in a model hub or in a temporary storage, and then later we will build again with it. The same way happens with data sets. We don't start directly ingesting the data set from the internet into the training pipeline. We do data cleaning, data transformations, and so on. So we have a loop at the beginning on the data sets. And we have a similar loop when we train the model. We might take temporary models, pre-trained models, and do fine-tuning on them. Or we might take a full model trained and do model quantization to deploy it on mobile devices, and so on. So this is how the entire ML supply chain would look like. It's like this diagram here. And every arrow here has associated risks. We have already seen the risks from training a simple model, so source tampering, injecting vulnerabilities, compromising the model storage, using a bad model, and exploiting bad models. But we also have risks associated with the other arrows. So a model can be poisoned, and this can impact either the model that you use in production or the model that you use for fine-tuning or before quantization. Similarly, data can be poisoned, and this will impact all of the training processes, and this will continue to cascade all the way until you get to production. And of course, you can also use bad training data while you train a model, either data that you should not be looking at, so you didn't have legal rights to train a model on that data, or data that is not doesn't make sense. It doesn't look like it doesn't look good to train on that data. Okay, so how do we fix this? The first solution is to make sure that once you train a model, you can no longer tamper with it. If we look back at the traditional software, we wanted, once a piece of software has been released, has been built, you wanted to make sure that nobody could tamper with that, nobody could change it. And in order to do that, people would resort to artifact signing. So we can do the same for model. We can sign the models with a cryptographic signature. And here we recommend using Sigstore, which is similar to Let's Encrypt for HTTPS certificates. Sigstore aims to do the same for digital signatures. And how does it work specifically for ML? Let's say I am the model trainer, and I start my training process. And as part of the training process, I contact the Sigstore certificate authority with some identity token that I get from an OIDC provider, and so on. The Sigstore certificate authority gives me a certificate that is valid for only a short period of time, which I can then use to sign the model. When I do this, when I sign the model, the signing event is stored into a transparency log. So anyone that has access to that log, any observer, can see all of the models that I signed in the past. And I get a result back from the transparency log. I get the inclusion proof. So now at this point, I have the signed model, I have the certificate that I signed it with, and I have the inclusion that this signature is in the transparency log. I can upload everything to the model hub, and the model hub would verify that the model is signed, and then display it in the model card. It can display a label that says, this model has been signed by this identity. You can go back, look into the transparency log, and see all of the other models that this user has released. So now when model users want to download the model, they can have some trust. They can say, I trust this identity versus I don't trust this identity. They already had some bad model in the past. I don't want any other model from them. And every user can have different policies regarding trust that can be built on top of Sigstore, as we will see a little bit later. So what we can do with Sigstore, we can sign the models as they get trained, and this way we can protect them from the moment they are trained all the way until the end of the pipeline, until they get to production. Or because the training process is expensive and models are huge, we might not want to sign every checkpoint and every model and do that for everything. We might want to only sign the models that go into production. And we are also looking for a future where we are going to sign datasets. So each time you do a dataset transformations, you are going to sign the final output. So somebody that has right access to the data storage cannot manipulate the data. Now let's move to the next level. So we have seen several arrows in here, but the signing only offers protection for a few transformations. What if we want to protect everything under the supply chain? This is where SALSA comes into play. SALSA stands for Supply Chain Levels for Software Artifacts. And the important part here is the levels. The SALSA specifications specify several tracks. Each track has levels. So let's focus on the build track. We have level 0, which means there is no SALSA. And then level 1 would say you can specify how you build your artifact. Level 2 would add additional protections. Level 3 would add additional protections on that, and so on. So this makes it easy, both for you to know what you need to do in order to accomplish the security guarantees of a specific level, but it also makes it easy to talk to executives and VPs and partners saying, we have trained this model at level 2. They will know there is a SALSA level 3, so they will know, like, do we need to invest to get to the next level of security, or is this level enough for now? So how does this work for ML? What is the difference between signing versus attestation versus a SALSA? In signing, you can only compute a checksum of the artifact and then sign that. And as the subject of the statement that you sign, you have the digest. In an attestation like SALSA, you still have the digest of the model, so we still need to hash the entire model, but you can add additional metadata fields. So in SALSA, we can record, you have trained the model with this version of TensorFlow, this version of ML training framework. You have used this data as input. You have used this many GPUs. The training happened at this time of day, was started by this person, and so on. Both the attestation and the raw signing, they are signed cryptographically secure. So the signature, once you generate the provenance, once you generate the document, it cannot be tampered with. Now, if we apply SALSA for ML training pipeline, we can apply it for every transformation of a data set. We can generate a SALSA provenance. When we train a model, we can include all the data sets, all the frameworks, all the pre-trained models into the provenance that we generate. Each time we quantize a model or do fine-tuning, we can generate a SALSA provenance that will say this final model has been built from this input model. Each time a model gets taken from the model hub and put into a production application, into an application, we can record as part of the provenance for the application that the application uses this model. So with SALSA, we can record every piece in the supply chain. The only issue now is that we are going to have a lot of statements, a lot of attestations. And we need a way to combine them all together to understand the entire supply chain. And this is where the third piece of technology comes in. This is Guac, which tries to build a knowledge graph of all the metadata that we have built so far. So imagine that I have a SALSA attestation about an application that uses ML, and that attestation refers to a model. This model also has a SALSA attestation that says how it was trained. And inside this attestation, it says that it uses this data set. And I have an attestation for that data set that tells me where I downloaded it from. I can ingest everything into Guac, and this will tell me the entire story of how this model got generated, what data got into the model, who trained it, what framework, and so on. This is very useful because in case I have a compromise somewhere down the line, I can quickly build out blast radius. I can quickly determine which models that are used in production I need to retrain, and which models I don't need to retrain, they are safe. This would result in significant cost savings because I don't need to retrain everything, would result in faster incident response because now I know exactly what I need to fix, and can also prevent future attacks because now I understand where the malware could come into my system. And in a diagram form, we basically start with the trust foundation, where 6 stories. That's where you do the signatures. On top of that, we can build attestations, software attestations. So I talked about Salsa, but there are others like SBOMs, scorecards, and so on. This is where Salsa is. And on top of all of this, we can aggregate everything together. This is Guac. But the nice thing is that once you have all of these 3 layers, you can go to the last layer, the policy and insight, which means that you as a big organization, when you want to deploy an application that has ML in it, before the launch, you can see the entire story of how the model has been developed, what the data has been used, and so on. You can check if it complies with all of the licenses. You can check if it complies with all of the security development procedures, and so on. And all of these checks are being automatically done because you are using data that is human and computer readable. And then it's easier for you to make a go, no-go decision to say, like, it's okay to release this application or not. Actually, it's even easier because now if you have all of this stack together, you can shift left as much as possible. So you can have an ML developer that tries to start a model training on a bad data set. You can have the policy engine tell them, hey, you are not supposed to train a model on this data set because the data set is under an unacceptable license for us. Okay, so if you go away from this slide, from this talk with just one idea, the idea is that we can protect the ML supply chain exactly the same way we do it for traditional software. And we can do this even if the ML supply chain has additional risks added to it. And now I will move to the final slide for questions. We have a repository under SigStore for model signing. We have a white paper about the ML development that you can read, and you'll see like all of the supply chain risks and how they appear and how Google thinks about them and what open source can look at to protect against the risks there. And then if you are interested in working with this, we have an OpenSSF working group on AI and security, and we have an OpenSSF special interest group on model signing. They are both under the OpenSSF calendar. Everyone is welcome to join. Once you join the meeting, you can also join the OpenSSF Slack, and we can do a lot of discussions there. And a lot of this work has been done under Google Secure AI Framework. So the last QR code is for that. And one of the principles of SAIF is that we want to expand the strong security foundations that exist in the world to the ecosystem. And I think now I will stop for questions.
Looks like we don't have any questions, so maybe if you have a few slides left, you can complete.
No, that was the last slide. Thank you.
Oh, that's really amazing. So I was like very interested in what you were saying. So I thought there is some more to it. But yeah, that's an interesting talk.
Yeah, thank you. Thank you.
Awesome. So it was a pleasure having you here with us, and I hope you have a great time here as well.
Yes, thank you. Thank you.
Awesome. So that was the last talk of our AIML track for the TIL conference. I hope you guys have a lot of fun speaking to and listening to speakers as well. So yeah, that's it from my. It's not over yet. you can still watch other streams as well, because I think there are but most people left for the streams. But that's it for the AI able track here. So thanks a lot everyone who joined this conference and who watched us till the end and who supported us here as well. So yeah, see you next time.